returned. I returned. I slept for 5 hours. And I just feel so unrested. But I also feel very awake. So here we are. I've returned to Spaceman time and Spaceman land to do Spaceman things. Like eating cashews. Cashews are delicious. Alright, let's see. Where did we leave off? Yesterday we made good progress. We extended them all to include all possible resources. We got those all piped into the same chute network where they can get sorted, go to different directions. So this portion's all wired up and working correctly. And at least now we can manually route stuff into our various crafting devices. Today, I'm looking to start programming these a little in particular. It's time to get these things from being manual to being automatic. And I think I was thinking I'd start with programming this section first. I think this is pretty easy to do. We want to specify how we use these things. We're not going to walk up and click the button so much. We're going to set how many things we want to make with 100s dial, 10s dial, 1s dial, and then flip a switch to turn it on, and then also be able to flip that off if you want. But I think that's pretty easy to do. That's something I wanted to write. And then that's also going to pull this guy and drop stuff. It'll all collect into the center, drop right here. This is the goal. So this is what we're looking to do. For beginning, I need to get the chutes finished. The chutes are almost done. We made enough to finish the job while I was AFK. I AFK'd for just a little bit. Sat in the AFK tube just so we could see the water continue to go up. See the chutes get crafted. But things are good. Live, laugh, love. Let's do some little bit of crafting. I was thinking too, I'm about out of food, aren't I? How are we on food? We have a little bit of food. That's enough food. Screw it. But we're gonna have to start cooking our own potatoes soon. I was thinking I needed to set that up now, but I think we've got time. All right. Chutes. Chutes, chutes, chutes. Almost done with these chutes. It's been a big project. It's a good one though. Chutes go up to the ceiling for all of the outputs. Alright, these guys should move towards the center. Hopefully without bumping into lines. How's the power look? Maybe okay? Might need a little adjustment. It's not a problem. I was thinking I wanted to do black on the ceiling. good with the white ones? I think so. Let's change these to black. Alright, so we come up to the ceiling. We're looking to drop like right here, I think would be a good spot. Just right in the center of everything. So let's merge these together. What's going on with the wires here? I think we can just go around. Okay, that looks good. That makes room here. Alright, so these guys can window into each other. And then we need a junction, which can go... How does that work? It needs to go this way. Maybe this. Where's dead center? I want it to go to right here. Okay. Let's do something like this is okay. That's not a window. Alright, that guy's plugged in. This guy is plugged in. So these two collect and go into this spot. And then they will need to merge with these two. Let's do a similar pattern over here. Jetpack low. Alright, how should these merge? We can do that first. Needs to go this way. Like that. Should be okay. Alright, there's one of them. You need to route to here. Okay, that goes there. The cabling here needs adjustment. Can probably just extend this line. Let's see. There, good enough. Alright. So these two merge into here. These two merge into here. These two need to merge. And then drop. Where do we want to drop? Somewhere around here is probably good. I think that's pretty perfect. Let's do this. How's that? Is that dead center? Eh? I'd rather be a little bit over this way. Okay. So we merge them and then drop straight down. I think this spot looks good. Is that where we want it? Basically exactly. Should be right here-ish. I think that's about right. I think it's, I literally want it like halfway in between these two. This is okay. It's there, it's right here. I'm gonna keep it. That's good. Alright. Connect. Close enough. Could be a little janky. Gives a character or something. Mostly I don't have to fix it. That's the most important bit. Alright, so these all come together now. And they should just drop in the center of the room. We could test that a little. Can you give me another shoot maybe? No, you can't. I'm gonna feed you some stuff. Auto lathe is two. Oh, you're out of stuff? Damn. I'm gonna feed you this. Because I can. I'm going to tell you to make a plastic sheet. Alright, so that gets pulled. Nice. Good thing we're testing. Immediately fails. Very first shoot. Programming. Alright. Are you going to work now? Oh yeah, that's gonna rain things. I think that looks good. Alright, let's put that ceiling back on. Hello, kitty cat. Did you have good window time? You're so pretty. I love you. Kitty cat's very confused about what time of day it is and when you should be asking for food. My sleep schedule is messy right now. Should be perfect for Battlefield release, though. Gonna be awake like right when it's releasing. Where did that go? How did I lose a tile? I'm sure we'll find it. Alright, let's go ahead and store some stuff real quick. This is basically the shoot bag now. You gotta paint that cladding. Can't have a missing tile. Gross. Alright, that's looking good. Feels like it needs lights or something. But this is a good start. I just like the look of it. Looks like a complete chaos. That's fun. Alright.
Hydration critical.
You thirsty guy? Guy's thirsty. Alright, so these are all wired in now with the chutes. The physical wiring to pipe stuff around. Looks like it's all ready to go. It's all controlled via this one switch. What else? I was thinking I want to adjust the windows really quickly, actually. Doubling up the windows looks way better. Even if it's like the exact same color, it looks way better for whatever reason. I want to do that again. Let's try and make things look nice. I I'm not sure if the rotation here matters at all. I should probably do these rooms as well. Because why not? Looks better. Alright, that's all the side windows. Did I get these? I don't think I got these. There it is. And you are a reinforced window. Alright, and then the ceilings too I haven't gotten. Almost done here. And this is gonna need a bunch of glass. I'm sure we don't have enough glass. Glass. Glass forever. Have some more glass. Okay. Let's fill that in and see if it looks better. I think it will. Oh, I wonder if it even makes sense to leave them as like half built. Just do the frame but leave the glass. Instead, you double up the glass, which makes it look a little worse. Interesting. Maybe we just do this and call it good. I'll play BF6. Seems good. We'll see. Tomorrow. One day. You have to have 1 day patience. Me too. Hello, kitty cat. That's kind of a neat look already. I think I might want to leave it white. White doesn't look bad.
Jetpack low.
Matches all the white everywhere else. Oops. How are we doing? Did you do the thing? Did the thing? Pull the lever. Marines materials. Does this hurt? Nope, right in the eyes. Feels good actually. Builds character. Okay. Do I like the white? Debatable. I do want to do... oops. I'm going to do cladding right here. Shouldn't be a window. Can at least hide it. White's not bad. I was thinking I want to see what this looks like. The window's just kind of blending in a little more. You're already purple. Oh, I painted the outside purple. Whoops. That one too. Whoops. Game is hard. I like that more. Tempted to make this white. The white on blue is pretty good. What does it look like blue on blue? Ah, it feels cleaner. I'm doing it. Important colors. Look how much better that looks. I do like that more. Okay. So we have this guy all shooted up, and we got some beautiful windows. Let's do the programming on the IC chips here for these guys. That'll be fun to do. If you don't mind, give me 1 second. I'm gonna run downstairs and just shut the window now that the cat's not hanging out in it anymore. It's like midnight. Probably shouldn't be leaving the window open. Give me just 1 moment. 43 minutes until my baked potatoes are ready. I've got 43 minutes to write this script if I want to put artificial deadlines on it for no reason. Let's see. It takes as long as it takes. I don't think this will be a bad one. So we want to write some code here. We're writing code to manage the dials, which we can give some labels. We want a hundreds dial, or probably just hundreds. Tens. Ones. And then activate. Or start. Start, stop. Run. Yeah, I think that's okay. Then our stacker. This is gonna be our, what is this, auto lathe? Pipe dude? Pipe dude. Pipe. Stacker. Okay. So for its variables then, it's gonna have a auto lathe or hydraulic pipe bender. We're probably gonna have to rotate through a bunch of stuff here. Might be a little obnoxious, but that's okay. Not the end of the world. It's like all the computers and all the sorters and everything's plugged into this. Here we go. Getting closer. Where is that pipe bender? Pipe bender where? Hydraulic pipe bender. We'll have the hundreds. Tens. I'm getting ahead of myself a little here. So now we're gonna have to define the code to have this. Oh, big kitty! What's up, Desdicon? Hope you're doing good, dude. It's a very distracting big kitty. He's always so beautiful. Big kitty's doing good. He had a nice walk yesterday. We're looking for ones here. Okay. Last thing is the run switch. find it. I feel like it should be run switch, not just run. I wanted it labeled nicely for when we're looking at it like this. Where are you, run? Did I not plug you in? I might be missing a plug. There it is. So many things. Okay. Writing a program. You got a chippy dude in you? Let's go ahead and I'm just going to make a completely new program for this, I think. Let's start from nothing. Or start from the template. Where's template? So what did we have here? We had our D crafter is a generic term, because it could be the pipe or the electric one or whatever. We have our D100 D100s. D10s. D1s. And then we had our D run switch. Okay, so I think that's right. Let's go ahead and save this. This is called crafter controller. Seems reasonable. Controls your crafters. Very helpful. Let's confirm this, let's export it, let's put it in and just make sure that we wired these parts up correctly. You should be doing nothing right now. So the crafter is the pipe bender, the hundreds is the hundreds, tens is tens, ones is ones, run switch is run. Okay, so you're all plugged in nicely. And I wanted to check something else out. What happens if I change the name? If I call you run switch, does that affect the programming without any effort? It does. So when we're wiring it up, I can give a specific name to this, and then when we're done, we can just have them all share the same name, but it'll be a different device, if that makes sense. So we can have the same label for all of these buttons on all of the inputs, and this can always be run. Seems good. Okay, so let's see. Let's do some ads. No ads. Get out of here, dude. They keep trying to sell me adult diapers. It's been months. I've not purchased a single adult diaper in my entire life, fortunately. So far. For now. It's been a hot debate, but that's a different subject. Anyway, they keep trying to sell them to me and I don't even buy them. Nobody deserves that. What are we doing? We've got all our various things. These are our inputs. Those are plugged into the devices. Those are already wired in. So we need to write some actual code here. Starting with just the blank boring template, which will have a main function that yields for a second, loads variables, comes right back to here, does whatever it needs to do, jumps to main, just loops forever, constantly checking state and doing stuff. So this program, we want to collect I think it's going to need stages first off. It's going to run in different stages. So it'll start in like an idle stage until you flip the activate switch, and then it'll go into an activating stage, or like a running stage. It'll need to, when the switch, it'll sit in idle. When the switch gets flipped, that means go ahead and get started. It'll need to collect the count on the dials and put that into an integer and store the actual number of how many things we want to create. And then it needs to go through the loop of creating that thing that many times. Every jump, it should be rotating dials so that the dials are keeping current with whatever's actually internally going on. And then when it's done, if it reaches 0, it needs to flip the switch to off. It needs to wait a second or so and then pull the chute so that everything gets dropped into the exit slot and comes and rains down on our head. And then it needs to go back to idle. I think that's pretty much what we're going to do. We probably also want to add some logic for canceling, so that if you mess up or you just want to build something else, you can flip a switch to cancel. And we might want to add a bit of logic. We should do like lock logic. When it turns itself on, when it's running, it should lock the thing and then unlock it at the end, so we can't even accidentally mess it up or like go click buttons on the screen So I think that's what we want to do here. We also, depending on how many lines of code we have and how convoluted we want to make it, we could add more custom logic for every individual device. This would be a good spot to handle, in fact, now that I think about it, this is a really good spot to do this. We could handle checking internal state and seeing what's the various values on all of the materials. And if you get below a threshold of maybe 200, then try and send a signal to the mall and demand whatever you're missing, and that'll come down the pipes. So I think this might be a good place for that, because basically we can take the D crafter's internal memory, and that's going to be accessible for all the various crafting devices. Otherwise they're a little bit of a pain to access. I was thinking of maybe like we could store the name of them in the stack and just kind of like do a for loop or do a loop over the stack to grab whatever name we wanted, name hash, but they have a different item hash for all of them, so that kind of complicates things. It's a little obnoxious. Anyway, this might be a good spot for that. It's either that or we write that as its own individual program, which is what I was originally thinking, where, like I said, it'll loop over the devices and then it will access their memory and send them things if they need it. So this is that's like a long essay without a single line of code. Just kind of thinking through what we want to do here, how it's going to look. Let's take a swing at that. We can start off with stages. We have examples of variables. This is doing a temp and a max temp with a constant and a variable. We're going to do something different. We're going to do a stage, and we're going to have things like stage idle, which can be a 1. And then what stages do we have? What was I saying? We have stage idle, we have stage like crafting, maybe. Stage cancel. Stage completed. Something like that seems good, perhaps. And then these need to have a different value for each stage. But we're just defining a constant for every single stage that we might want to have here. And then we're going to be assigning that into our vStage variable. This guy is going to tell us what the stage is. So we will say, to start off, we want to move that stage to be stage idle to begin with. Okay. What else do we have here? We're going to load values from all sorts of things. We're going to have the DV hundreds, be R14. This is going to be the value in the hundreds. So we need to keep track of the values in all of the dials along with the activate switch. So V100s alias V10s are 13, alias V1s are 12, alias V run switch is on, is R 11. I think that's an okay name. Usually this is like a boolean that I would manually control, and we are going to be controlling the run switch, but I think we can, it's like read only basically. We're going to specifically set it to 1 in the code when we're at the correct spot in the stage, or set it to 0, I mean. Alright. What else do we have? What else are we collecting here? Anything else? Probably have like v num loops, something like that, or v loops remaining, something like that. We need to keep track of how many loops we have left to go, or how many items remaining. Or even v item count. Trying to get the right label here so that the code comes together more cleanly. What are you labeled exactly? You're the item count, which isn't like, it's not like an I, it's not like an iterator. It's like the items, it's the total item count on the hundreds, the tens, and the ones. Thirsty boys, thirsty. Thirsty boys, hungry. The night rages. Cool, dude. I love this new lighting mod. This looks so much better. Alright, what was I doing? Stuff and things. I already want to save this. It's done a bunch of stuff. Let's overwrite this. Alright. We ate, we drank, we could pause, but I want to keep running the clock. While we're running the clock, things are only getting better. I have to eat and drink. I'm going to have to cook a potato someday. But how's our water going? Water is 732. Pretty sure that's up. I'll keep an eye on that. That's enough for, that's like hours of runtime. But I just want to make sure that number keeps going up. I want to see it get totally filled. And then have it shut off water production and our fuel will pile up. Alright, where was I? Let's see. So we have our various stages. We've got a couple of variables for the item count and whatnot. If we wanted to tack in some logic for managing the device, we could, but I think I don't want to do that. Let's at least get this portion done, and then maybe we just add like a part of the run that happens every time is just to manage sending stuff if it's needed. That might only be a couple lines of code. And we have access to all the devices we need. We could even plug in another variable if we want. But we could just use hashes too. Anyway, let's get this moving. So we can start with loading variables. We go into our main function. We jump to load variables. Load variables needs to load the variables. So let's start loading stuff. Alias, or we're gonna load into the V100s, the D100s. And then the setting is whatever value is on that dial, which should be 0 to what? You can do whatever, but maybe 9. Probably 0 to 9 for everything. Load V10s is going to be D10s setting, 0 to 9. Load V1s, D1s setting, 0 to 9. Okay. We can use this to quickly compute, what is it? The item count. Load the, nope, not load. Add the item count is going to be just the, let's see. Okay. So real quick, we'll use some temporary registers here, just for like one line of code, basically. I think that's an okay spot for them. I don't think we want labels for these variables. But we need to tweak these. This is the 100 spot, the 10 spot. These need to be changed. Let's go ahead and say multiply into R0, V100s, times 100. Multiply into R1, V10s, by 10. And then we can add these. We don't need to do any multiplication on the ones. It's already good. So we will say the V item count is going to be the addition of our V1's spot and the R1 to add the 10s. Or we'll do R0, add the item count to itself, R1. Okay, so we're grabbing the 10 setting, or the 100 setting, which is 0 to 9. We're grabbing the 10 setting, which is 0 to 9. The 1 setting, which is 0 to 9. These are corresponding to, like, the column they're in, basically. 100's column, 10 column, 1 column. So with that in mind, we have to change the value. If the 100's column is 9, it's not 9, it's 900. So we are multiplying the 100s by 100 and storing that in our temporary value, R0. We're doing the same for 10s, multiplying it by 10s. And then we're just adding that all together into the item count. So now we have the item count is just a normal, plain old integer from like negative 32 billion or whatever to positive that. So this will have, it doesn't really matter what we put on the dial, so we could go crazy with it and have tens and hundreds and millions of items, and it would be fine. But it's not going to do that. It's probably going to go up to like 1,000 at max. You turn everything to 9. Okay, that seems good. I'm going to confirm that, and then we should probably program these two, or change their settings, because they're not quite right now. You go to 9. Okay, and then we can rotate these to do however many you want to do. So you do like 951, go, and it poop out 951 insulated tanks, which would be very expensive. So we're not going to do that. Okay, that's progress. Let's see. So we are getting the item count all prepared. What else do we need to load? We need run switches on. Load the run switches on is the run switch setting. Okay. I think that's basically all the variables that we need to collect here. So that's the first thing our main function is always going to do. It's going to wait 1 second, or wait 1 tick, and then it's going to load the variables, calculate the item count, get what the switch is at, and we'll do a little more soon. We're going to need to add the loading of memory. We'll need to load the internal memory, because I think that's how you drive running this thing, if I recall correctly. And we're going to need to tell it to turn on and keep track of whether or not it's running. Coffee is good. So our main function is going to load variables, and then it's pretty much just going to decide what switch are we taking based on the current stage. What function should we execute? Coffee is really good. So we will say branch if equal the stage idle should go to stage idle, and then we should make a function for stage idle, which is going to do things and stuff, and when it's done, it's going to jump to main. And we just do this for every single stage. Stage crafting is going to go to stage crafting, and we need stage crafting. Coffee's so good. I can't control myself. How many do we have? 2 more? Alright. Then we just need to make these. Stage crafting, jump main, stage cancel, jump main, stage completed, jump main. Okay. Stage completed. There we go. Alright, so we've got some stages now. Our main function is going to load everything it needs to load, compute some values, and then we can jump into our stages with good current values in all of the various variables. So we can use that to drive our logic here. Stage idle is just going to sit here and chill until someone switches the button. So we are going to say, let's see, what's our variable here for button? Run switches on. So we'll say branch if equal to 0. Run switches on. Main. So if the run switch is off, then just go ahead and go to main and just keep looping until you eventually have the run switch be on. And at that point, we're going to enter line 32 because we're not going to branch away. So this is time to start running. We move into the stage. Stage crafting. I think it's stage craft and stage crafting. Let's do stage craft. And let's add that as an intermediate stage. But maybe that's not necessary at all. Maybe we click the button right here is the right spot. I'm going to stick with just crafting. And we get rid of this line of code. Okay, so we go to stage crafting. And we need to start crafting. So for that, we need to do something. I'm not sure exactly what. Let's investigate. Pipe bender. I think this uses the internal memory. And it's going to be a little tricky. I haven't done that before. So, might have to consult the wizard here and talk to ChatGPT. See if he can give me a line of code that helps us out. Activate is read or write. Activate, I think, would be click the button. I think we just click activate. We need activate, and then we need to track running. We need to see when it's done running and use that to trigger another activate and to change the count, I think. Just looking through this API. Oh, there's a prefab hash. That's nice. Okay, so this is a variable we need in our other program for running them all. We can just grab the prefab hash, I think, and use that to drive things. Anyway, I'm not seeing what I want to see here. I think there's memory, internal memory, is where we're going to find some of the stuff I'm interested in. And I'm not exactly sure how to use this. This is where the wizard ChatGPT will come in and help. I've not played with internal memory before. I think we give it a pointer to an address in the stack. There's like a specific index that has the information you're interested in, and it's just always at this indexed location. So I think we can look into that, and then you have to AND it. You'll get it'll give you a single big piece of information where the first 7 bits are the operation code, and then it's got a stack address in the next chunk, and then unused here. But this is where you just have to extract whatever you're interested in. So here's missing regent. There'll be an op code. There'll be quantity cell. There'll be regent hash, and those are located based on the address, the bits in this one big thing of memory. So if you want to extract the op code, then you have to AND it with ones on those first 8 bits, and then you'll delete basically everything except the one opcode you're interested in. And so I could think you might have to do the same thing here, and then even shift it. So AND it and then shift it all the way over, and then you'll get whatever value you're interested in. So I'm not exactly sure what that looks like, but I think it is just 2 or 3 lines of code that you have to get right that are a little tricky, and we can use that to collect stuff. So let's see, execute recipe, for instance. If we wanted to change the recipe, maybe this could be a way to do it. You can give it a quantity and then give it whatever you want it to craft. I don't think we want to do this. I think we just want to do activate. The quantity thing is only an 8-bit byte. If I remember right, it can only go to 255. So it is going to be less than if we use the dials and are maintaining the internal variable ourselves as a bigger integer. That's an int 32 for the bigger integer internally. Instead of 8 bits, we get 32. So just kind of looking at this and thinking about what we might want to do here. Got to do a little learning. Haven't played with this before. We can lock it here. Does it not have lock? It does have lock. Alright, well let's go ahead and start crafting. So to start crafting, I want to set the D crafter. We're going to lock it. So we'll set lock to 1, and then we'll set D crafter activate to 1. Okay. So that should just start crafting. I actually want to test even that. Let's see if this will work. I'm going to save, throw something in, turn it on, decompile. No explosions. Let's craft anything. Give me a... You have nothing? There's nothing in you? That's amazing. What do you need? Steel and silicon. You are the pipe dude. Pipe dude is 3. Steel and silicon. Alright, give me some pipes. Oops, that's not what I want. I want to try this. Okay. So that's working. And then we don't have any more logic, but I just wanted to at least see that. And now you're locked. Perfect. I can't touch it. Alright, we're getting 200 pipes, I guess. Alright, just gonna dump everything into pipes. It's fortunate that I need infinity pipes. It was a good choice. Alright, I'm gonna save already. I'm just gonna take a step away from all this noise. Let's listen to the sound of the whales in the pipes. And some sad piano. Alright, let's see. So, this is working. It went to stage crafting. It locked and it activated. That's good. Stage crafting, we want to see... We want to track how it's affecting the number for like the item count, basically. We want to be seeing when it is going down, when it's finishing crafting a recipe. And then we want to change that counter. And now that I think about that, so activate, we just click the button and it goes forever. But this would be a good use case for execute recipe. Instead of clicking activate, we should update the memory to do execute recipe to just craft whatever is the selected prefab hash. Don't change this at all. Just craft one thing now, because then it will run, it'll do one cycle, and then we can see when that finishes and immediately just do it again. So it'll take a small break in between every item, but we're talking like, I think, a half second per item. So maybe that matters a little bit if you're making pipes. It's going to take an extra 100 seconds to make 200 pipes. I don't think that's a huge deal. And that would allow us to track things, and then we can change the dials to match whatever the internal state is. So you can kind of keep an eye on what the count is, and just like have everything automatically go to 0. So you'll always just like turn the dials up. Whenever the use case will always be you walk up and the dials are at 0. And you just turn the dials up to whatever you want. Click go. You don't have to like check every dial. You can trust that it's 0. That's a lot of words. Alright, how do we do this? What do you have to say, Chat GPT wizard? Stationeers. Execute. Recipe. In internal memory. Go, 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 go. Don't fucking suck this time. give example assembly code. This should be just like one line of code. I'm looking. I'm looking. I'm looking at my black rectangle. It's learning me things. It's not the best viewpoint for you folks, unfortunately. Do I have to install ChatGPT on my computer? I feel like if I install ChatGPT on my computer, it's going to take over. It's going to take over the computer, and it's not going to tell anybody, and it's going to start the singularity, and it's just going to be all sorts of headache. Okay. So I think it gave us some example code that we can play with here. And it's just a couple lines. So we can give that a shot and see what happens. I think it's given us our magic 2 lines of code we need to make this work. We can try and figure out what they do, play with them a little bit. But we're just looking to use the execute recipe instead of activate in particular. Let's see. And actually, we should probably add an unlock right here. Maybe not. So I'm thinking it would be nice right now to unlock. And generally speaking, if we're in the idle stage, we want to be unlocked because you need to be able to search through and select whatever the various recipe is that you want to craft. So where do we want to set lock to 0? I was thinking basically along in the flow would make sense. Once we're done with the crafting phase, or if we do the cancel. We could write cancel right now. That's not a bad idea. Okay. So stage crafting. Stage crafting, one of the first things it can do is check if we need to cancel. Let's go ahead and see the run switches on.
Hydration critical.
Okay. Let me write this out and then I'll explain it. Just 1 second. Branch if not equal to Z. Run switch is on. I'm going to branch 3 lines of code relative. Otherwise, if our run switch has switched to 0, which means that I have tried to cancel it, then we want to set lock to 0. Let's unlock it. Or that should happen in stage cancel. We want to set the stage, move the stage to stage cancel. Yeah. And then we want to jump to main. Okay. So the first thing the crafting loop is going to do when we're in the crafting stage, it's going to branch relative. If the vrun switches on is not equal to 0, it'll jump 3 lines. So if we turn it on and the thing is running, and this is a 1, then it's going to jump 3 lines to right here and keep doing whatever it's going to do. And right here it's going to want to like monitor the run state, basically. But, however, if we flip that switch to cancel it, which is something we want to do like right now, but there is a chance we just want to interrupt a job, basically. Then we go into stage cancel. Stage cancel should set activate to 0 perhaps. We might need to explicitly set, or like there might be one of those instruction codes for just like stop. But I was thinking if we set execute recipe for 0 quantity, that would probably make it stop immediately. How do I make you stop? Is there a variable for that? If I set activate to 0, is that going to turn it off? We could try that. This is probably simplest. So stage cancel, we set activate to 0, so we're just going to turn the thing off. And then we should also set the dials to 0, I think. Set the D100s setting 0, set D10s setting 0, set D1s setting 0. We should wait for a second to let anything in the pipes go through into the stacker, and then we should pull the stacker as well. So set the D, let's see, no, we just want to sleep here. Let's sleep for 1 second, 2 seconds. I imagine 1 second's fine. It needs to just go around like one little tiny bend. This is 2 ticks. Hopefully that's enough. Okay. And then we want to pull the stacker. Do we have the stacker even plugged in? I see no stacker. So we will add stacker. So we'll set the stacker. What does it activate? I'm not sure. What are your variables, dude? Probably activate. That's probably pull the handle. Okay. So cancel is going to turn off the crafting device. It's gonna set all of the dials to 0. It's gonna wait a second. So if there's anything in the tubes, they go through. It's gonna pull the stacker to release anything in the stacker that's been building up, and that'll get dropped into the center of the room. And then it's gonna change the stage to stage idle. And it'll resume just spinning and waiting for something to happen. Activate, or the switch will also be a 0 here. And we might even want to explicitly set that. We shouldn't need to, but I think it almost makes sense. Nah, screw it. I think we're good. Okay. Let's confirm. Let's export. Let's check the weather. How's the weather? Warm. Dude's dying. You got a food, dude? Get in there. Okay. Just looking at things. I'm going to turn this off so it doesn't change settings on anything. We just added a stacker, which is named what? Pipe stacker. Let's find pipe stacker. It's a lot. There's a lot of things. There's so many things. An overwhelming amount of things. Okay. Alright, so I want to test that. What do you need? You're still locked, right? If I activate you, you'll start running. And then if I cancel you, will you unlock? No. No unlocking. But you do stop. take a look at that. Why aren't you unlocking? Is it because I don't tell you to unlock, probably? Yup. That'll do it. Set D crafter lock 0. Alright, you work now? Okay. Did I see you get pulled? You're still pulled, right? Okay. So that... the functionality is you click it like a button and it pulls and goes down. But if you set it programmatically, then it stays. So... potatoes! Okay, so that means that you need to activate and then you need to sleep for even a single tick. So that's a yield. And then you need to deactivate. So pull it for 1 tick, release it immediately. How's that? Oh, does it stop automatically? Is activate 1 thing? That would be perfect. Or did you get canceled somehow? How are you getting canceled? Is it something to do with how we're activating? Because we should be in stage crafting right now. Just looping and doing quite literally nothing. So there shouldn't be anything getting triggered here. And we can confirm that too, because when I flip the switch and it cancels, that means it's just been doing this loop over and over until it jumps into stage cancel and does its cancel loop and goes back to idling. There's nothing in there. No rain. Not sure exactly what's going on there. Gotta figure it out. I need to take food out of the oven real quick. And ads are coming. I'll be back in just 1 second. We can debug this. 43 minutes until my baked potatoes are ready. I've got 43 minutes to write this script if I want to put artificial deadlines on it for no reason. Let's see. It takes as long as it takes. I don't think this will be a bad one. So we want to write some code here. We're writing code to manage the dials, which we can give some labels. We want a hundreds dial, or probably just hundreds. Tens. Ones. And then activate or start, stop, run. Yeah, I think that's okay. Then our stacker, this is gonna be our, what is this, auto lathe? Pipe dude? Pipe dude. Pipe, stacker. Okay. So for its variables then, it's gonna have a auto lathe or hydraulic pipe bender. We're probably gonna have to rotate through a bunch of stuff here. Might be a little obnoxious, but that's okay. Not the end of the world. It's like all the computers and all the sorters and everything's plugged into this. Here we go. Getting closer. Where is that pipe bender? Pipe bender where? Hydraulic pipe bender. We'll have the hundreds. Tens. I'm getting ahead of myself a little here. So now we're gonna have to define the code to have this. Oh, big kitty! What's up, Desdicon? Hope you're doing good, dude. It's a very distracting big kitty. He's always so beautiful. Big kitty's doing good. He had a nice walk yesterday. We're looking for ones here. Okay. Last thing is the run switch. I'm gonna find it. I feel like it should be run switch, not just run. I wanted it labeled nicely for when we're looking at it like this. Where are you, run? Did I not plug you in? I might be missing a plug. There it is. So many things. Okay. Writing a program. You got a chippy dude in you? Let's go ahead and I'm just going to make a completely new program for this, I think. Let's start from nothing. Or start from the template. Where's template? So what did we have here? We had our D crafter is a generic term because it could be the pipe or the electric one or whatever. We have our D100 D100s. D10s. D1s. And then we had our D run switch. Okay, so I think that's right. Let's go ahead and save this. This is called crafter controller. Seems reasonable. Controls your crafters. Very helpful. Let's confirm this, let's export it, let's put it in and just make sure that we wired these parts up correctly. You should be doing nothing right now. So the crafter is the pipe bender, the hundreds is the hundreds, tens is tens, ones is ones, run switch is run. Okay, so you're all plugged in nicely. And I wanted to check something else out. What happens if I change the name? If I call you run switch, does that affect the programming without any effort? It does. So when we're wiring it up, I can give a specific name to this, and then when we're done, we can just have them all share the same name, but it'll be a different device, if that makes sense. So we can have the same label for all of these buttons on all of the inputs, and this can always be run. Seems good. Okay, so let's see. Let's do some ads. No ads. Get out of here, dude. They keep trying to sell me adult diapers. It's been months. I've not purchased a single adult diaper in my entire life, fortunately. So far, for now. It's been a hot debate, but that's a different subject. Anyway, they keep trying to sell them to me and I don't even buy them. Nobody deserves that. What are we doing? We've got all our various things. These are our inputs. Those are plugged into the devices. Those are already wired in. So we need to write some actual code here. Starting with just the blank boring template, which will have a main function that yields for a second, loads variables, comes right back to here, does whatever it needs to do, jumps to main, just loops forever, constantly checking state and doing stuff. So this program, we want to collect I think it's going to need stages first off. It's going to run in different stages. So it'll start in like an idle stage until you flip the activate switch, and then it'll go into an activating stage, or like a running stage. It'll need to When the switch, it'll sit in idle. When the switch gets flipped, that means go ahead and get started. It'll need to collect the count on the dials and put that into an integer and store the actual number of how many things we want to create. And then it needs to go through the loop of creating that thing that many times. Every jump, it should be rotating dials so that the dials are keeping current with whatever's actually internally going on. And then when it's done, if it reaches 0, it needs to flip the switch to off. It needs to wait a second or so and then pull the chute so that everything gets dropped into the exit slot and comes and rains down on our head. And then it needs to go back to idle. I think that's pretty much what we're going to do. We probably also want to add some logic for canceling so that if you mess up or you just want to build something else, you can flip a switch to cancel. And we might want to add a bit of logic. We should do like lock logic. When it turns itself on, when it's running, it should lock the thing and then unlock it at the end so we can't even accidentally mess it up or like go click buttons on the screen. So I think that's what we want to do here. We also, depending on how many lines of code we have and how convoluted we want to make it, we could add more custom logic for every individual device. This would be a good spot to handle, in fact, now that I think about it, this is a really good spot to do this. We could handle checking internal state and seeing what's the various values on all of the materials. And if you get below a threshold of maybe 200, then try and send a signal to the mall and demand whatever you're missing, and that'll come down the pipes. So I think this might be a good place for that, because basically we can take the D crafter's internal memory, and that's going to be accessible for all the various crafting devices. Otherwise they're a little bit of a pain to access. I was thinking of maybe like we could store the name of them in the stack and just kind of like do a for loop or do a loop over the stack to grab whatever name we wanted, name hash, but they have a different item hash for all of them, so that kind of complicates things. It's a little obnoxious. Anyway, this might be a good spot for that. It's either that or we write that as its own individual program, which is what I was originally thinking, where, like I said, it'll loop over the devices and then it will access their memory and send them things if they need it. So this is that's like a long essay without a single line of code. Just kind of thinking through what we want to do here, how it's going to look. Let's take a swing at that. We can start off with stages. We have examples of variables. This is doing a temp and a max temp with a constant and a variable. We're going to do something different. We're going to do a stage, and we're going to have things like stage idle, which can be a 1. And then what stages do we have? What was I saying? We have stage idle, we have stage like crafting, maybe. Stage cancel. Stage completed. Something like that seems good, perhaps. And then these need to have a different value for each stage. But we're just defining a constant for every single stage that we might want to have here. And then we're going to be assigning that into our vStage variable. This guy is going to tell us what the stage is. So we will say, to start off, we want to move that stage to be stage idle to begin with. Okay. What else do we have here? We're going to load values from all sorts of things. We're going to have the DV100s to be R14. This is going to be the value in the hundreds. So we need to keep track of the values in all of the dials along with the activate switch. So V100s alias V10s are 13, alias V1s are 12, alias V run switch is on, is R 11. I think that's an okay name. Usually this is like a boolean that I would manually control, and we are going to be controlling the run switch, but I think we can, it's like read only basically. We're going to specifically set it to 1 in the code when we're at the correct spot in the stage, or set it to 0, I mean. Alright. What else do we have? What else are we collecting here? Anything else? Probably have like the num loops. Something like that. Or V loops remaining. Something like that. We need to keep track of how many loops we have left to go. Or how many items remaining. Or even V item count. Trying to get the right label here so that the code comes together more cleanly. What are you labeled exactly? You're the item count. Which isn't like, it's not like an I, it's not like an iterator. It's like the items, it's the total item count on the hundreds, the tens, and the ones. Thirsty boy's thirsty. Thirsty boy's hungry. The night rages. Cool, dude. I love this new lighting mod. This looks so much better. Alright, what was I doing? Stuff and things. I already want to save this. It's done a bunch of stuff. Let's overwrite this. Alright. We ate, we drank, we could pause, but I want to keep running the clock. While we're running the clock, things are only getting better. I have to eat and drink. I'm going to have to cook a potato someday. But how's our water going? Water is 732. Pretty sure that's up. I'll keep an eye on that. That's enough for, that's like hours of runtime. But I just want to make sure that number keeps going up. I want to see it get totally filled. And then have it shut off water production and our fuel will pile up. Alright, where was I? Let's see. So we have our various stages. We've got a couple of variables for the item count and whatnot. If we wanted to tack in some logic for managing the device, we could, but I think I don't want to do that. Let's at least get this portion done, and then maybe we just add like a part of the run that happens every time is just to manage sending stuff if it's needed. That might only be a couple lines of code, and we have access to all the devices we need. We could even plug in another variable if we want, but we could just use hashes too. Anyway, let's get this moving. So we can start with loading variables. We go into our main function, we jump to load variables. Load variables needs to load the variables. So let's start loading stuff. Alias, or we're gonna load into the V100s, the D100s. And then the setting is whatever value is on that dial, which should be 0 to what? You can do whatever, but maybe 9. Probably 0 to 9 for everything. Load V10s is going to be D10s setting, 0 to 9. Load V1s, D1s setting, 0 to 9. Okay. We can use this to quickly compute, what is it? The item count. Load the, nope, not load, add the item count is going to be just the, let's see, okay. So real quick, we'll use some temporary registers here, just for like one line of code basically. I think that's an okay spot for them. I don't think we want labels for these variables. But we need to tweak these. This is the 100 spot, the 10 spot. These need to be changed. Let's go ahead and say multiply into R0 V100s times 100. Multiply into R1 V10s by 10. And then we can add these. We don't need to do any multiplication on the ones. It's already good. So we will say the V item count is going to be the addition of our V1's spot and the R1 to add the 10s. Or we'll do R0, add the item count to itself, R1. Okay, so we're grabbing the 10 setting, or the 100 setting, which is 0 to 9. We're grabbing the 10 setting, which is 0 to 9, the 1 setting, which is 0 to 9. These are corresponding to, like, the column they're in, basically. Hundreds column, 10 column, 1 column. So with that in mind, we have to change the value. If the hundreds column is 9, it's not 9, it's 900. So we are multiplying the hundreds by 100 and storing that in our temporary value, R0. We're doing the same for 10s, multiplying it by 10s. And then we're just adding that all together into the item count. So now we have the item count is just a normal, plain old integer from like negative 32 billion or whatever to positive that. So this will have, it doesn't really matter what we put on the dial, so we could go crazy with it and have tens and hundreds and millions of items and it would be fine. But it's not going to do that. It's probably going to go up to like 1,000 at max. You turn everything to 9. Okay, that seems good. I'm going to confirm that, and then we should probably program these two. Or change their settings, because they're not quite right now. You go to 9. Okay, and then we can rotate these to do however many you want to do. So you do like 951, go, and it poop out 951 insulated tanks, which would be very expensive. So we're not going to do that. Okay, that's progress. Let's see. So we are getting the item count all prepared. What else do we need to load? We need run switches on. Load the run switches on is the run switch setting. Okay. I think that's basically all the variables that we need to collect here. So that's the first thing our main function is always going to do. It's going to wait 1 second or wait 1 tick, and then it's going to load the variables, calculate the item count, get rid of what the switch is at. And we'll do a little more soon. We're going to need to add the loading of memory. We'll need to load the internal memory, because I think that's how you drive running this thing, if I recall correctly. And we're going to need to tell it to turn on and keep track of whether or not it's running. Coffee is good. So our main function is going to load variables, and then it's pretty much just going to decide what switch are we taking based on the current stage. What function should we execute? Coffee is really good. So we will say branch if equal the stage idle should go to stage idle. And then we should make a function for stage idle, which is going to do things and stuff, and when it's done, it's going to jump to main. And we just do this for every single stage. Stage crafting is going to go to stage crafting, and we need stage crafting. Coffee's so good. I can't control myself. How many do we have? 2 more? Alright. Then we just need to make these. Stage crafting. Jump main. Stage cancel. Jump main. Stage completed. Jump main. Okay. Stage completed. There we go. Alright, so we've got some stages now. Our main function is going to load everything it needs to load, compute some values, and then we can jump into our stages with good current values in all of the various variables. So we can use that to drive our logic here. Stage idle is just going to sit here and chill until someone switches the button. So we are going to say, let's see, what's our variable here for button? Run switches on. So we'll say branch if equal to 0, run switches on, main. So if the run switch is off, then just go ahead and go to main and just keep looping until you eventually have the run switch be on. And at that point, we're going to enter line 32 because we're not going to branch away. So this is time to start running. We move into the stage. Stage crafting. I think it's stage craft and stage crafting. Let's do stage craft. And let's add that as an intermediate stage. But maybe that's not necessary at all. Maybe we click the button right here is the right spot. I'm going to stick with just crafting. And we get rid of this line of code. Okay, so we go to stage crafting. And we need to start crafting. So for that, we need to do something. I'm not sure exactly what. Let's investigate. Pipe bender. I think this uses the internal memory. And it's going to be a little tricky. I haven't done that before. So, might have to consult the wizard here and talk to ChatGPT. See if he can give me a line of code that helps us out. Activate is read or write. Activate, I think, would be click the button. I think we just click activate. We need activate, and then we need to track running. We need to see when it's done running and use that to trigger another activate and to change the count, I think. Just looking through this API. Oh, there's a prefab hash. That's nice. Okay, so this is a variable we need in our other program for running them all. We can just grab the prefab hash, I think, and use that to drive things. Anyway, I'm not seeing what I want to see here. I think there's memory, internal memory is where we're going to find some of the stuff I'm interested in. And I'm not exactly sure how to use this. This is where the wizard ChatGPT will come in and help. I've not played with internal memory before. I think we give it a pointer to an address in the stack. There's a specific index that has the information you're interested in, and it's just always at this indexed location. So I think we can look into that, and then you have to AND it. You'll get it'll give you a single big piece of information where the first 7 bits are the operation code, and then it's got a stack address in the next chunk, and then unused here. But this is where you just have to extract whatever you're interested in. So here's missing regent. There'll be an opcode. There'll be quantity cell. There'll be regent hash, and those are located based on the address, the bits in this one big thing of memory. So if you want to extract the opcode, then you have to AND it with ones on those first 8 bits, and then you'll delete basically everything except the one opcode you're interested in. And so I think you might have to do the same thing here, and then even shift it. So AND it and then shift it all the way over, and then you'll get whatever value you're interested in. So I'm not exactly sure what that looks like, but I think it is just like 2 or 3 lines of code that you have to get right that are a little tricky, and we can use that to collect stuff. So let's see, execute recipe, for instance. If we wanted to change the recipe, maybe this could be a way to do it. You can give it a quantity and then give it whatever you want it to craft. I don't think we want to do this. I think we just want to do activate. The quantity thing is only an 8-bit byte. If I remember right, it can only go to like 255. So it is going to be less than if we use the dials and are maintaining the internal variable ourselves as a bigger integer. That's an int 32 for the bigger integer internally. Instead of 8 bits, we get 32. So just kind of looking at this and thinking about what we might want to do here. Got to do a little learning. Haven't played with this before. We can lock it here. Does it not have a lock? It does have lock. Alright, well let's go ahead and start crafting. So to start crafting, I want to set the D crafter. We're going to lock it. So we'll set lock to 1, and then we'll set D crafter activate to 1. Okay, so that should just start crafting. I actually want to test even that. Let's see if this will work. I'm gonna save, throw something in, turn it on, do compile, no explosions. Let's craft anything. Give me a, you have nothing. There's nothing in you? That's amazing. What do you need? Steel and silicon. You are the pipe dude. Pipe dude is 3. Steel and silicon. Alright, give me some pipes. Oops, that's not what I want. I want to try this. Okay, so that's working. And then we don't have any more logic, but I just wanted to at least see that. And now you're locked. Perfect. I can't touch it. All right, we're getting 200 pipes, I guess. All right, just gonna dump everything into pipes. It's fortunate that I need infinity pipes. It was a good choice. All right, I'm gonna save already. I'm just gonna take a step away from all this noise. Let's listen to the sound of the whales in the pipes. And some sad piano. Alright, let's see. So, this is working. It went to stage crafting, it locked and it activated. That's good. Stage crafting, we want to see... We want to track how it's affecting the number for like the item count, basically. We want to be seeing when it is going down, when it's finishing crafting a recipe. And then we want to change that counter. And now that I think about that, so activate, we just click the button and it goes forever. But this would be a good use case for execute recipe. Instead of clicking activate, we should update the memory to do execute recipe to just craft whatever is the selected prefab hash. Don't change this at all. Just craft one thing now, because then it will run, it'll do one cycle, and then we can see when that finishes and immediately just do it again. So it'll take a small break in between every item, but we're talking like I think a half second per item. So maybe that matters a little bit if you're making pipes. It's going to take an extra 100 seconds to make 200 pipes. I don't think that's a huge deal. and that would allow us to track things, and then we can change the dials to match whatever the internal state is, so you can kind of keep an eye on what the count is and just like have everything automatically go to 0. So you'll always just like turn the dials up. Whenever the use case will always be you walk up and the dials are at 0, and you just turn the dials up to whatever you want, click go. You don't have to like check every dial. You can trust that it's 0. That's a lot of words. Alright, how do we do this? What do you have to say, Chat GPT wizard? Stationeers. Execute. Recipe. In internal memory. Go, 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 go. Don't fucking suck this time. Give example assembly code. This should be just like one line of code. I'm looking. I'm looking at my black rectangle. It's learning me things. It's not the best viewpoint for you folks, unfortunately. Do I have to install ChatGPT on my computer? I feel like if I install ChatGPT on my computer, it's going to take over. It's going to take over the computer, and it's not going to tell anybody, and it's going to start the singularity, and it's just going to be all sorts of headache. Okay, so I think it gave us some example code that we can play with here, and it's just a couple lines. So we can give that a shot and see what happens. I think it's given us our magic 2 lines of code we need to make this work. We can try and figure out what they do, play with them a little bit. But we're just looking to use the execute recipe instead of activate in particular. Let's see. And actually, we should probably add an unlock right here. Maybe not. So I'm thinking it would be nice right now to unlock, and generally speaking, if we're in the idle stage, we want to be unlocked because you need to be able to search through and select whatever the various recipe is that you want to craft. So where do we want to set lock to 0? I was thinking basically along in the flow would make sense. Once we're done with the crafting phase, or if we do the cancel. We could write cancel right now. That's not a bad idea. Okay. So stage crafting. Stage crafting, one of the first things it can do is check if we need to cancel. Let's go ahead and see the run switches on.
Hydration critical.
Okay. Let me write this out and then I'll explain it. Just one second. Branch if not equal to Z. Run switch is on. I'm going to branch 3 lines of code relative. Otherwise, if our run switch has switched to 0, which means that I have tried to cancel it, then we want to set lock to 0. Let's unlock it. Or that should happen in stage cancel. We want to set the stage, move the stage to stage cancel. Yeah. And then we want to jump to main. Okay. So the first thing the crafting loop is going to do when we're in the crafting stage, it's going to branch relative. If the vrun switches on is not equal to 0, it'll jump 3 lines. So if we turn it on and the thing is running, and this is a 1, then it's going to jump 3 lines to right here and keep doing whatever it's going to do. And right here it's going to want to like monitor the run state, basically. But, however, if we flip that switch to cancel it, which is something we want to do like right now, but there is a chance we just want to interrupt a job, basically, then we go into stage cancel. Stage cancel should set activate to 0, perhaps. We might need to explicitly set, or like there might be one of those instruction codes for just like stop. But I was thinking if we set execute recipe for 0 quantity, that would probably make it stop immediately. How do I make you stop? Is there a variable for that? If I set activate to 0, is that going to turn it off? We could try that. This is probably simplest. So stage cancel, we set activate to 0, so we're just going to turn the thing off. And then we should also set the dials to 0, I think. Set the D100s setting 0, set D10s setting 0, set D1s setting 0. We should wait for a second to let anything in the pipes go through into the stacker, and then we should pull the stacker as well. So set the D, let's see, no, we just want to sleep here. Let's sleep for 1 second, 2 seconds. I imagine 1 second's fine. It needs to just go around like one little tiny bend. This is 2 ticks, hopefully that's enough. Okay, and then we want to pull the stacker. Do we have the stacker even plugged in? I see no stacker. So we will add the stacker. So we'll set the stacker. What does it activate? I'm not sure. What are your variables, dude? Probably activate. That's probably pull the handle. Okay. So cancel is going to turn off the crafting device. It's gonna set all of the dials to 0. It's gonna wait a second. So if there's anything in the tubes they go through, it's gonna pull the stacker to release anything in the stacker that's been building up, and that'll get dropped into the center of the room. And then it's gonna change the stage to stage idle. And it'll resume just spinning and waiting for something to happen. Activate, or the switch will also be a 0 here. And we might even want to explicitly set that. We shouldn't need to, but I think it almost makes sense. Nah, screw it. I think we're good. Okay. Let's confirm. Let's export. Let's check the weather. How's the weather? Warm. Dude's dying. You got a food, dude? Get in there. Okay. Just looking at things. I'm going to turn this off so it doesn't change settings on anything. We just added a stacker, which is named what? Pipe stacker. Let's find pipe stacker. It's a lot. There's a lot of things. There's so many things. An overwhelming amount of things. Okay. Alright, so I want to test that. What do you need? You're still locked, right? If I activate you, you'll start running. And then if I cancel you, will you unlock? No. No unlocking. But you do stop. Let's take a look at that. Why aren't you unlocking? Is it because I don't tell you to unlock, probably? Yup. That'll do it. Set D crafter lock 0. Alright, you work now? Okay. Did I see you get pulled? You're still pulled, right? Okay. So that... the functionality is you click it like a button and it pulls and goes down. But if you set it programmatically, then it stays. So... potatoes! Okay, so that means that you need to activate and then you need to sleep for even a single tick. So that's a yield. And then you need to deactivate. So pull it for 1 tick, release it immediately. How's that? Oh, does it stop automatically? Is activate 1 thing? That would be perfect. Or did you get canceled somehow? How are you getting canceled? Is it something to do with how we're activating? So we should be in stage crafting right now. Just looping and doing quite literally nothing. So there shouldn't be anything getting triggered here. And we can confirm that too, because when I flip the switch and it cancels, that means it's just been doing this loop over and over until it jumps into stage cancel and does its cancel loop and goes back to idling. There's nothing in there. No rain. Not sure exactly what's going on there. Gotta figure it out. I need to take food out of the oven real quick. And ads are coming. I'll be back in just 1 second. We can debug this. I'm back with potatoes. So I'm swapping out the way we're activating here. Let's try using the example code that affects the memory directly and just tells it to do like 1 thing. So for that, we're gonna have to get the hash of whatever's been selected by the device, because that's part of the memory. And then we just need to steal some code from the wizard ChatGPT here and see if this helps us out. Let's see. What is this? Alright, let's see. Alright, we're combining these into an instruction. What is SSL? It's shifting stuff. Okay, so this is doing what I was talking about. So like this is taking whatever hash code and shifting it 16 bits to the left. So we just got to do a little bit of shifting on stuff to get the instruction set up right. And then we just set the instruction, I believe. Let's get some better variables here. Alright, what are we doing? What is this? We're taking a hash and we're shifting it 16 bits to the left. We're doing an 8-bit shift on the value. And then we're merging this all together. We got the R0 and the instruction itself here. So we're merging these together, and we're merging it with just a 2, which is the opcode for not stacker. Give me the pipe bender. The opcode here is 2. So we're setting the opcode, we're setting the quantity by shifting 8, and then we're setting the hash by shifting 16. That makes sense. We're just putting this all together in one big value that we then throw into memory. So this is all looking correct. I think the only thing we're missing here is we're missing the hash code. I don't know what the hash code is. Is the recipe hash? I'm guessing this is what it is. Yeah. Okay. So let's collect this too. We'll have the alias v recipe hash. It's going to be R8. And then that is going to just be loaded as part of our initial loading of variables. Is going to be the crafter recipe hash. Okay. So we load the hash as part of the startup. We form the memory. What's it called? It's not activate. I want to actually use the right name here. What's your recipe? Execute recipe. We create the execute recipe call for the memory, and then we store it into memory. And it just pushes it into the stack and then gets consumed, I'm guessing. I wonder if we need to like clear the memory as we're using it, if if we're just shoving stuff into the stack, that's going to eventually be problematic, I would think. Maybe it's just shoving it into the 0 slot every time. Do this every time. And then eventually it'll overflow, but it's old stuff that doesn't matter. Maybe. Haven't played with this at all. I haven't set internal memory. I think this is making sense. Skip the recipe hash here. Okay, so this is going to create an instruction, and it's going to store it in the memory. This should tell it to make one of whatever is selected. Okay. So that's a big part of it. What about detecting if it's running or not? Can I see is running as a variable here? Is that something easy to access? Do I have to go into memory? Completion ratio. So maybe when it gets to either 1 or 0. I wonder if I could just like mod 1 on it. See if there's a remainder. Anyway. So we're setting this. This should start running. It should create one thing. Let's actually test this right now. This should be progress. We should be able to tell it to do something now. Maybe. This might have fixed the bug, but let's see if the activate switch will now actually activate. Do you work? Are you gonna make a thing? Nope. Immediate failure. Unsurprising. Let's see. It did behave differently though. It didn't do the activate. It also didn't do anything. Let's see. Oh. Let's see. Just trying to think what's going on here, what could be going wrong. One thing I can think of, I feel like the instruction should be getting wiped. Like we should initially say move the instruction 0. That's one thing. Otherwise, when we're doing calls later, we're gonna OR stuff. Everything might just like turn to 1 and start doing the wrong thing. So let's make sure we're clearing the instruction before we do anything. But this should have only executed once. We should have been in stage idle. We should have let's see. It should have been waiting until the run switch was flipped, and then it should have just set the stage to crafting and done this whole thing. All we did is swap out this whole chunk. This used to be an activate call. Now it's a memory call. So I think the general flow is probably still working right. It'd probably be a good idea as well to put like a debug console out there. Kind of like that idea. I might do that real quick. Let's throw down a debug console just to get a little more info. Let's see. Could do a couple if we wanted to. We'll say debug. What should you be called? I want to see the item count maybe. Or even the memory. Let's take a look at the... We can do whatever we want here. Item count's fine. Stage is when I wanted debug stage. I'm gonna keep the weird labeling on these. Alright, let's turn these on. So we can just like delete these eventually and we can do very little to our code and just immediately start debugging stuff. So we could do the item count. Let's see. We can do that as part, I think right here is where we want to write stuff. We can set batch, device hash. We need the hash for consoles. Define console is going to be the hash of a console. LED small. Let's call this console small. So set by name, console small. The name hash is, what's the name here? Stage. Debug stage. Logic type is setting. It's going to be the value that is displayed on the console. The value here, I just want to see the stage. Show me the stage. So that should put debug stage with the correct value. And since it's just a console, it's a hash here, so we don't have to wire it in. We're just specifically targeting any console on the network that has the specific name debug stage. So we can do debug stage, debug recipe, or no, what did I do? Item count. That can be v item count. So just like this real quick will give us a little bit more info. Let's maybe try and give it some items. Let's say I'm gonna do 1, 2, or even let's do 111. See if that'll work. Gonna save, I don't know why. I'm gonna turn this on. 111 in stage 1. Okay. Activate in stage 2. So we went from stage idle to stage crafting. We should be here now. But we didn't see any instructions go through. Let's see. Let's take a look at the. I'm gonna keep the stage there. I'm gonna leave this as debug item count, just so we don't have to do anything. Just doing some debug. Let's see what the v instruction is. Oops. Oh, that's interesting. That's not right. Uh-oh. Is that because everything's 0? Nothing's 0. That's amazing. It is not the right value there. Or no, that might be. Sorry. I was thinking something different. So, can I write this down? No, come on, get out of the way. Am I gonna have to like print screen or something? Paint. Give. Paint. No. Paint. There it is. 1, 5, 6, 3, 8, 9. 3, 8, 9, 7, 6, 5, 1, 4. I hope that's right. I need to see bits. I just want to look at this and see what the various values are. I suppose we could AND it with stuff. I want to see what it looks like in binary. Oh, come on. Just fucking... Am I gonna... Don't make me consult ChatGPT. ChatGPT's already failed me once today. Come on, Google. You can't do binary conversions? Dice, please. Okay, I think that's looking mostly right. So I think something funny might be going on with how we're activating. I added to memory, nothing happened. Does the memory need to be affected in any other way? Does it need to be cleared or something? Does it need to be changed? I think I remember nerds on Reddit talking about clearing stuff. Oh, maybe we set that and then we activate.
Hydration critical.
Okay. Let's try that.
Hunger caution.
Maybe it's like specifying what to do for the next activation, and then you say set DB or set, what is it, D crafter activate 1 maybe. Don't need that anymore. Export, you go here. Alright, what happens now? Nothing. Nothing happened again. Okay, when the idle state. 0, 0, 0, 1. Ooh. Shit. It just did nothing. Who's done this? Who knows what I'm doing wrong? Someone backseat game us to victory. I was told there would be backseat gaming. Alright, so why aren't you working? What's going on here? Just doing a quick look at the binary code here. It looks like things were right. I could verify more, but it seems pretty straightforward. This doesn't seem to be working ever. I wonder if we should like clear the memory as part of startup, maybe? I don't think that matters. We could. How do you clear memory? Just clear. Okay, that couldn't hurt. Export. Clear the memory, maybe? Nothing's happening. Let's see. To clear the memory, you drink a bottle of whiskey by yourself. That sounds difficult. I think that would kill me. Let me see if I can consult the Reddit. What are we looking for? Set recipe? What's the name of the functionality? I think we got it in our code comment. Execute recipe. Station years, Reddit, execute recipe. Hmm. Hmm. How do I make you do the thing? I'm just looking through the code. So what's this doing? Let's look at what it's doing for creating this memory. I think this is right, but it's worth looking over again. We're wiping it to 0 in the very beginning. We're taking whatever recipe hash has been given to us, and we're shifting it left 16 bits, which if we look at the API for the pipe vendor, execute recipe has an opcode of 2, so that's in the very beginning is the opcode. It has a quantity shifted 8 bits, and it has a hash shifted 16. So hash is 16, quantity is 8. I'm gonna flip these, so I don't know why you do it that way. I'm even gonna do this. So we set instruction to 0. We put a 2 for the very first portion. The first byte is going to be a 2 for the opcode, which is the opcode for execute recipe. Goes there. The quantity is going to be 1 shifted left 8. So that's the quantity being set to 1. And then we're going to OR that in as well. Suppose we could just like set it as 2 to begin with. I don't mind doing it this way. This feels clean. We OR the instruction with R0, which is going to set that first one. This shouldn't be there. Let's do R0 again. Things are moving around. I think changing the order of the code is kind of changing how this is written. Anyway, we're going to do the same thing. So recipe hash gets shifted 16 bits left into R0, and then that gets mixed in with an OR, just reusing R0 as a temp variable here. And let's see, let's double check that. Recipe hash is 16 bits left. Okay. So I think the instruction's looking good, and when I was just taking a quick look at it online, it seemed fine. We're putting that into the stack at instruction slot 0, and then it's just like not doing anything. How do I tell it to execute its memory? Do your thing. I would expect it to just automatically do that, but maybe not. Maybe recipe hash is wrong. Why? Why don't you work? Who knows? Someone knows and they're just sitting there laughing at me right now. Confess. Alright, program's getting pretty long. Let me eat and drink and stuff. Bro's getting near dying. And how about the water situation? Is water still going up? We're up to 808 liters. Okay, and I wanted to check something too. For the water, I think the coolant is hanging out at like 160. What is 160 Celsius? 160 is 875. I was just thinking we want to We can compress it and have it be a little hotter if it's going to move faster and compress faster on the condensation portion. That would be a good thing. Let me just go take a quick look at that.
Oxygen critical.
I need to use jQuery. jQuery can do everything. Did you see jQuery in the interview? Where's my laptop? Where is my white laptop? Did it jump into a random container? Maybe. Did I throw it on the floor? Likely. Alright, I give up. Just wanted to look at this. What are you set to? 320 kilopascals? What does 320 give us? 320 is 172. So this is right about where it is. The coolant's at like 160. There's only a 10-degree difference. I bet if we turn the pressure up a bit so that the temperature goes up, that it would start condensing faster. And I do need my white laptop. I want to see how much buildup we have here. We've got a turbo pump that forces all the steam through. But I just want to see the values. And yeah, I think if this goes up. 420 blaze it. Is that perfect? What's 420? 180. Let's do maybe at least 200, 500 pressure. Okay, 520 should give us 200-ish. That's probably fine. So that should dump more heat in the coolant and dump more heat in our general cooling system, but condense faster, I believe. So hopefully, and I can see condensation in the pipe. This is probably pretty high pressure. Where's my laptop? I want to look at this. Oh, I found you. Very well done. Very sneaky. Got a couple liters of liquid. It might even make sense to put a drain on this. No. We don't want to drain on this. We want to be pumping it to vacuum, basically. So there has been buildup here. This should be going faster now. Should have a more latent heat, I think, too. Up to 1.4 kilojoules. What's your temperature? 180. So that's like immediately matching. Right? What's the pressure? We did 520, I think. What did I put you at? 520 Celsius. It's like 20 degrees off. And rising. I mean, it might make sense to just basically put it all the way up here. Nah, I take that back. The more we can dump into the atmosphere, the better. So basically the issue is we don't have... This isn't cold enough. That's pretty easy to change. And also maybe pretty unnecessary to change. Our water is still flying upwards, but I just want to have crazy water income. If we can improve efficiencies pretty easily. Alright, so I'm just going to keep it in mind. I'm not going to do it right now. But we can just add a couple more vents if we want and another tank. And that'll just increase the amount of air in the system and increase the rate at which it can cool off when it's pumping in cold air from the night. That should help alone. But ideally, we want to keep this tied to like the outside temp of 130. It's 50 C above where it could be. Probably nitpicky. The pollution system is doing real good for cooling everything. It's not getting utilized like at all. It's still like completely full. Yeah, like at capacity. Anyway. What's going on over here? Why can't I make this thing work? Alright, so I think just that teeny change should affect the amount of water we're getting. We'll see. Let me see if I can find some example code for how to execute internal memory. I think we might be pushing it to the wrong spot. I think we're supposed to overwrite a more specific address, perhaps. Let's take a quick look at that. Pipe bender. Hydraulic pipe bender. Execute recipe only valid at addresses 0 to 53. Okay, so if we're doing address 0, that should be valid. We could take a look at the stack pointer, maybe. Are you missing stuff or something? No, you can craft this. Oh, you can't? Oh my god. If this is it, that would be amazing. Holy shit, that would be so good. You need iron, you need to be something else. What do I have? Can you do insulated something? No? I think we might have just been like out of regents. Okay, and I can see it's trying to craft the thing. That's interesting. It's got the wrong recipe hash there. And this is in stage 1, the idle phase, right? You're in stage 1. You should be idle. Does the memory need to be cleared? Is that what it is? If I reset this, you can just keep setting. Okay. Okay, so it looked like that was working. The fact that we were seeing it going, so we set the memory once upon a time while it was running. And then we saw that it was going to the vent over and over, which is what was set in the memory is the recipe hash that was supposed to be executed. So it was trying to do that. And then I think we need to clear the memory because it just kept trying to do that over and over and over. I'm not exactly sure how that works, but we could see that it was updating the memory and trying to craft stuff. It's just out of material, I think. That feels really silly. I don't think that's a bug at all. I think we just need to go farm some iron. All right, let's go farm some iron. That's the easiest thing in the world. But this might be working, or at least it's gonna be able to craft a little more. It seems like it wasn't starting and then stopping. Or I'm actually not exactly sure how it was starting and then stopping. If there wasn't iron in there. It didn't look like it was doing that anymore. Maybe activate behaves differently than setting memory. I am not sure. This is a new uncharted territory for me. I think we're getting closer though. Alright, let's go ahead and
Oxygen critical.
go farm just a little bit of iron. forgot my cheesy potatoes. I gotta eat those. Alright, I don't think we need much stuff right now. I don't want to spend much time farming. This is probably overkill. Where do I live? Alright, throw that in the chute for processing. Okay, pipe bender. Pipe bender is 3. Need to feed it some iron. Alright. Let's see. I'm gonna save. Let's go to the... maybe just a cheap pipe. Give me a normal gas pipe. Those are the cheapest. Alright, we're at 0 on everything. I'm gonna set it to 1. That doesn't matter at all right now, though. I'm gonna save just in case. Shouldn't matter. But I just want to see. Are you going to run? And should I take a quick look at the code? Anything to see in here? No, we're just storing that in the instruction. Okay. Double check that's been exported. Make a pipe, maybe. Can I change this? No, because it's locked. But it's not making any more. It only made the 1. I think that worked. Damn, I think it was working this whole time. It was right the first time. And then I just spent like 20 minutes figuring out that the thing was out of material. Feels programming. Okay, so this seems to be working. We are now able to... we're now able to execute just the 1 crafting. And we should be able to keep track of whether or not it's running. I think even just like the activate value might show us. Or no, the completion percentage, I remember. Let's try and load that. Is complete maybe? Okay. Completion percentage is the V D crafter completion percentage. Is that it? I remember this being just a simple variable here somewhere. Completion ratio. That's a better word for it. Alright, so let's keep track of the completion ratio. As part of booting up, let's unlock the crafter. Because that's been a thing. Alright, export that. Now you unlock. And I can... No? You fuck. Oh yeah, okay. This is okay. Let's try that again. Now you unlock? Yeah. You're doing what you're supposed to. I'm sorry I yelled at you. Okay. Alright, that guy's just weird now. Let's take a quick look. What is the completion percentage right now? Is it 0? Completion ratio is 1. Okay. So we're waiting for 1. Okay, so let's see. We got idle working. We are able to set an instruction to make a thing, and then it crafts a thing, and then it stops crafting a thing. We have the cancel working for when we want to interrupt, set everything to 0. So now stage crafting is going to monitor the run state. It's going to sit here and just watch the stage until it's completed. So set, let's see, branch relative if less than, or no. Branch if greater than, so if the branch if less than, if the V completion ratio is less than 1, then go ahead and just go to main. Alright, otherwise at this point, we have now reached the end, basically. Completion ratio is 1. We haven't canceled. We're done here. So with that, we want to... Let's see, what do we want to do when we're done? I think we want to subtract 1 from the item count. And then set the dials. And then tell it to run again. Okay. So we go to, let's see, let's subtract from the item count 1. And then apply this. Or let's actually move the stage as well. Let's do that first thing. What stage are we changing to? We're going to be changing to stage idle. We're going to change to stage idle. And it's going to see that the activate switch is still on. And it's going to set the instruction to craft a thing. Okay, so that's going to keep the loop going. It'll keep crafting. And I'm just thinking too, we might need to, we're going to have to keep track of the count and like factor that in to when it's going to shut off automatically. When the count hits 0, don't create anything more. Anyway, we have our item count. We've subtracted 1 from it. Then we need to set this into our various devices. So let's go ahead and what do we want to do? Is there mod? We can just mod. So we'll mod into R0. The V item count mod 100. I don't even know if we need to mod. I think we just like divide. divide and floor. Is there some sort of floor function? Floor? Oh my god, it's beautiful. Register equals largest integer less than a. So R0, R0 then. Largest integer less than R0. So this is going to chop off the end of it. Okay, so we're starting with the hundreds spot. We're just going to load this into a temp register R0. We're going to divide the item count by 100. So if the item count is like 110, then it's going to be like 1.1. And then we're going to floor it with itself, so it would go to 1. And that's going to be the setting that we want to put in to the hundreds column. I think this is correct. So then we set D hundreds into setting R0. Let's do the same for all of them. We're going to divide R0 the item count by 10, floor it, set D10s in the setting with R0. No, this isn't right, is it? I feel like we should be including a mod here. And I can't see chat. What's chat got to say? Nothing. That's okay. I think we need to include a mod here. Because if we divide, so let's say the 110 example, if we divide 110 by 10, we get 11, which is too much. So maybe we just take it and then mod 10. Or we could I think we could just mod, yeah. We just mod it by 10. So sure, you get 11, and then we mod 10 and it goes to 1. Then we do the same with the ones. So we floor it and then we mod it. A 0 or 0, 10. So we just mod it and do it. Mod it by 10, store that into itself. So in the example of 110, we would divide the item count 110 by 10. We get 11 in R0. And then the floor would pull anything off. We should probably do like 111. Get 11.1, floor it to go to 11. Mod it with 10 to go to 1. That's going to be the remainder. And then we store that in the 10s. The 10 becomes a 1. And then we do basically the same thing for the 1s. We don't need to divide the item count by 1. That's item count, right? And we don't need to floor it. We just say mod R0. The item counts 10. So in the 111, that's going to be 111. Mod 10 will be down to like 1, right? And then we would say set D1s, dones, set D1s, setting R0. Okay. Maybe. I wouldn't be surprised if there's something wrong here, but I think this is roughly correct. At the very least, we're thinking about what we want to do here more or less correctly, but looking to just get those things to decrement as we are changing things so we can keep track of what the count is. Let's see, and let's keep track of that too. We've got the stage. I wanted to track the debugged item count, right? Let's actually see what it's thinking for item count inside of the console that we have for this. Yes, there we go. So we've got the console that's named debug item count, and we'll just put the item count in that. That should give us an update. Alright, what are we doing here? We got the crafting. Crafting cancels when it needs to. If it is not complete, it goes to main. So it'll keep looping until it's done. And then when it is complete, we set the stage to idle. We decrement the item count. We do all that jazz to set the dials. We go to main. It's going to go to stage idle. Stage idle is going to keep crafting forever and ever and ever as long as the run switch is on. Okay. So I think right here we want to do an additional check. We want to say if the let's see, let's say branch relative if less than or equal. If the v item count is less than or equal to 0, then go ahead and go to state, let's see, sorry, we're going to do 2 lines here. 3 lines here. And then jmain. Alright, so branch relative if less than or equal, item count 0, 3. So this is wrong. This should be branch greater than or equal to item count 0. So branch relative greater than or equal to. If the item count is greater than or equal to 0, then branch relative, jump 3 lines. Jump 1, 2, 3. Jump to here and keep doing your thing. So keep crafting while the item count's above 0. However, if the item count is less than or equal to 0, we have to do not equal. We gotta remove the equal here. If the item count is less than or equal to 0, then it's gonna go to this line. We're gonna change the stage to stage cancel. We're gonna jump to main, which is gonna jump to stage cancel. Stage cancel does all of the stuff it needs to do to reset state. The only thing it's not doing here is we should also set the activate switch to be off. So set D, what's it called, run switch. Setting 0. So the cancel function here can be triggered by that switch being manually set off if we ever want to turn it off. And at the same time, we can just recall that cancel functionality up here, and we can trigger it to turn itself off when we've reached the point where the item count is below or equal to 0. So I think that should handle turning the dials down and then turning the thing off after the desired number have been crafted. That's a lot. I don't know if I believe it's gonna work. In fact, I don't believe it's gonna work. But I'm gonna try and see what happens. Let's do a pipe. Give me a pipe. And let's start testing this a little. I'll save, but it doesn't matter. So first off, everything's at 0, right? If I run it, nothing should happen. It should just turn itself off. Or just break immediately. Okay. Line 86. What's line 86 say? 85, 86, D, run, switch, setting, 0. Is it not like the setting? Isn't that what it is? Run, switch, setting. D, run, switch. You're mad, Lane? This is mad? Why you have to be mad? What's your state? Is setting the right thing to be playing with here? What's your configuration look like? Run, you have open, setting. Open and setting are the same. And let's take a look at the switch. Open is read or write, setting is read only. And I bet if we bother to actually read the error message, it says setting is read only. So, whoops. Let's see, run switch open. Export. Go on. Okay. Snooze ads, no ads. Get out of here, ads. Okay, so let's try this. Let's see. So I was just testing. Everything's 0. We should run it. It should immediately cancel itself. It looks like it was doing that, except it we had the wrong setting that we were using there. Okay, so it fights us, cancels, goes to 1, even pulls the thing. Okay, that's good. Can you make me 1? Did it do the thing? Sounds like the timing's wrong. Did you make 1? I think that's 1. I mean, that's 2. Let's double check. I'm not confident. Did you get set to 0? You did. Can you make me 11? Is that all getting computed correctly? Looks like it's computing the item count. That's good. Make me 11. 10, 9, 8. So I think we might need like a sleep. Okay, this is really close. And what are you? You're all at 0. I didn't watch these actually change. I'm not sure if this portion's working correctly. But I think it has to be. Otherwise this wouldn't be... This is getting set with every single load. It's getting set based on these dials. So I'm pretty sure this is tracking correctly, or that wouldn't have worked. Except for the fact that it's not, though. We need a little sleep in here, I think. Let's take a look. So it is crafting, and then when it's done crafting and rotating between the stages, it is going too fast. It's not giving time for the thing to leave. Okay. So let's say crafting... This is where we're doing our loop. This is when we're done crafting something. Right? So this is probably the appropriate time to tell it to just chill for a second. Sleep for like 2 seconds, maybe. Can we sleep even for 1? We want this to be as fast as possible. Let's take a look. I'm gonna save. Give me 2. Okay. Give me 2 of these. Give me 3 of these. Okay, timing's still not quite right. Let's do 2 seconds. How many ticks do you need to do your animation, dude? Can I click you? I shouldn't be able to click you. Okay, give me 11. It's getting close. Do you work? Nine. Come on. That's not 11. 9 is almost 11. 9 is dangerously close to 11. Never forget. Alright, what are you doing? Are you not counting down correctly? It looked like the switches were flipping immediately instead of like after it was done crafting. So that seems off. Let's take a look at that. Those shouldn't be getting affected until this point. We're already in the idle state. That seems odd. Let's try a lower value. What happens if I do something without a tens column? What if I just do, give me 3? What you gonna do? Okay, so that worked. I need to run ads. They're being forced ads, and I'm gonna use the bathroom real quick. Food is good. Coffee is good. Alright, where are we? Ooh, let's check water too. How's water? Water's still going up. Water is 876. Water go up. Not as fast as I'd like. Alright, what's going on here? It looks like it's pretty much working. Could have something to do with like the rollover of the columns, perhaps. Let's try 11 again and see what it does. How's the count gonna change? I think it's just a teeny bit fast. Yeah, it missed one, but it looks like it's counting down just fine. Okay. That's good. Yeah, it's just a little fast. It's like 1 every 5 or 6. It's missing. Okay, so I think if we just tweak that value a little more, instead of being a 2, if it's even like a 2.5, then, does that have to be an integer? Do I have to do 3? Okay. We can do that. Anyway, I'm going to overwrite this. We're going to call that good, I think. Do you work now? Are we good? Let's try 11 one more time. And then let's tell it to make like 111 pipes. It would be good. But I think this is looking right. And that was good practice for playing with the internal memory. Internal memory is not terribly difficult to interact with. We can use that pretty easily to just loop through the value of what it has for all of the resources and then request it from the mall. That's gonna just be another like one or two lines of interaction with memory. A very similar scenario, that's what I'm thinking. Okay, well I think this is good. We still need to do a bigger check with the 100 value, maybe. Are you 11? You're 11. So the timings are good. Just want to make sure everything looks good, and then we can update these 4 chips. And all of these guys will have that automation set up. I don't think we need the debug consoles any longer. We can set those up if we want to. We can leave it in the code. But, looks like it's working. I don't trust it. But maybe. Let's wire all these. All get the same code. Just point them to different buttons. Alright, you go on, you break. You go on, you break. You go on, you break. Let's label stuff. This is ones. Nope. 100s. For what's this? For electric. 10s. Electric. Ones. Electric. Run. Electric. Run. Tools. Yeah, you tools. No. Auto lathe. Run. Auto. Ones. Auto. 10s. Auto. 100s. Auto. 100s. Tool. 10s. Tool. 1s. Tool. Run tool. Okay, there's the labels for everything. We'll get back to that in a minute. Now we can wire all these in. So this is the electronics printer. This is the 100s electric. This is the 10s electric. Backwards was a bad choice. Run electric, no. It's so many. It hurts me. Can I just like, you know? No, that would be nice. Alright. Did I pass it? It's in there. I can see it's plugged in. Pins electric. I must have passed it. Yeah, I definitely passed it. Electric, electric, electric. So many clicks. I've never clicked this many clicks before. My clicker's getting tired. It's too many clicks. 10s electric. I knew it was there. Alright, 1s electric. almost done. Run switch, and is that it? Stacker. Run switch electric. There's so many things. This is brutal. Got him. Last one's the stacker. I didn't label these properly. Your stacker electric. Your stacker tool. Your stacker auto. Okay. Stacker electric. Got him. We did it. Oh my god. I didn't think it was possible, but we did it. Do you work? Alright. So that's plugged in. Next, tools. Crafter is the tool workbench thing. Guy. What are you called? Tool manufacturing. Manufacturer when? It's in there somewhere. I probably passed it. This is brutal. It's like they all need to be on the same circuit for the most part. It's pretty hard to avoid. And these guys need to be able to talk to all of the machines. Yeah. I'm gonna find you manufacturing. Got him. Easy. Hundreds of tools. Tens tools. Ones tools. Run switch tools. I want to blink, but I can't. Oh. There it is. Stacker tool. It's like way down here. I see stacker. Pipe stacker. Stacker tools. Alright. Last one. You are the auto lathe. So easy. Easiest one so far. I like you, auto lathe. Thank you. One's auto. No, hundreds auto. Got him. Tens auto. I must have definitely passed it. One's auto. Tens auto. One's auto. Run auto. I would love to be able to search. Run tool, run electric, run auto, stacker, auto. Okay. It's over. It's over unless it's not. I think we're pretty good there. Okay. What are we at? 2 hours? 2 hours and 40 minutes? It's a big project. A little more complicated than I thought. Probably a half an hour if that was figuring out this dude was out of iron. Well played. Well played, this dude. Okay, I think we're good. I did want to test. Let's do, give me like 111. Go. Those should all craft. They should stack. They should get released, and in a minute or two, we'll see 111 things fall down here. We might want to test some of the other ones too. Maybe not 111. Or maybe 111. This is fine. Ah, shit. These need to be programmed as well. Oh, it's out of batteries. Interesting. Does battery go space? Nope. I tried. So these just have the wrong top end on them. I think it's faster use screwdriver. Goes to 9. 9. 9. Zero to 9. Okay. Look how clean it is. Ooh. And they just make things. Alright, cables are pretty good. Give me 22 cables from you. Give me 33 cables from you. I don't need basketballs. You can just be weird. Alright, good. That's nice to have. That takes some time. But that automates production now. So that we can just turn stuff on, and if we're loading these dudes automatically with resources, it's not just gonna dump our entire inventory into pipes. And at any time we can run up and turn this off. But that's a better way of counting like a specific amount of things. Just double checking that all of these are working correctly, but we should see a pile here with 111, 22, and 3 things. So that's a good start. I was thinking I might want to take a stab at setting up the mall automation as well. That sounds like a fun project that isn't too crazy. Not a whole lot different than what we just did. But that would be a fun one to look at. That might not be bad at all. This painting is bothering me. Missed a spot. Much better. Okay, I was thinking too, I want to remove these claddings. And replace this with just normal frames. Which we can then paint. Okay. This feels like it would be a good spot for... I want to put like the logic chips, like here, here, and here. For whatever's handling the furnace logic, the mall logic, and then even the switch logic. Might be a better spot for it. You just like move that a couple lines. Oh god, we'll have to rewire it. Nope, you're stuck here forever. This is where you live now. I'm not finding that one. I have to find 2 things on the network. That could take forever. Traumatized. Purple. Purple helps. Alright, so we want a chip or 2 here. Let's add these to the line. Maybe take a stab at the item distribution. See if we can get that automated away. That one's gonna be tricky. Do you want to install 2042 yet? I resisted the urge. Haven't done it. What do we got? Like 12 hours? 14 hours? 22 hours. 21 hours and 40 minutes. And then I'm allowed to uninstall forever. How we doing? Something pooped something. That's the 33, so that one worked correctly. Good to see. How you doing? Are you locked and crafting and out of material? Is that what's going on here? Okay. Had 15 left and it ran out of material. And then it just like chokes up. So that's not good. I suppose we can do this, right? And that should reset everything, in theory. But I don't see it doing that either. So that's not good. Looks like it chokes up. I'm guessing it is still like running, basically. How could this be happening? What's the code look like here? What happens when we hit this condition? What's going on? So we ran out of ore when there was 15 left. I flipped the switch and it didn't look like it did anything. So I'm guessing we are... Where are we? Stage crafting, maybe? I might have pulled up the debug stage console too early. Let's put that down right now. You are are the debug console. Debug stage. Stages in 1. Stages in idle. Alright, so somehow the stage got to idle. I feel like part of idle should be unlocking it. If we're in idle stage, it's just chilling. There's no reason to lock. As soon as we get to crafting, it'll lock up. I think that's pretty okay. Alright. Immediate bugs. Small tweaks, make it smarter. So we don't have to rewire these at all, but we do need to reprogram them.
Hydration critical.
Are you still running? You are off, but you're still running. You're running forever. Even though it's at 0, no, you're at 2. You're not moving anymore. Uh-oh. Also, you are all on the same network, and you're going to be fighting the console commands here. So this could be any of these devices. Could be you, could be you. Gotta be a little more careful with that. Do you do one at a time? Let's see. You go here, we will export. You go there. You should turn off. Suspect. You're misbehaving. How many things did you make? $111. That's exactly what you were supposed to make of the pipes. Coincidence? They're conspiring. This one's talking to that one, and they're making fun of me with 111. You all saw. It makes sense. Don't think about it. Okay, so something's off here. Is it anything in the programming? 100's auto. 10's auto. 1's auto. Run auto. Stacker auto. Auto lathe. Auto. That seems okay. Not sure why I kept crafting forever. Did I click the button or do this? Maybe I just used it wrong or something. What happens if we tell you to make 2 of the wires? And also, I want to program you first. Let's program you and change the program. We're going to comment out the stage and this one. So you get no comments, or you don't affect that console. That's been commented out. The only one that affects the console right now is this one. So we can use that to track the stage and see what's going on, not have an interfering signal. Alright, so we're gonna reprogram all of those. Now I want to test this. What happens when we tell you to do 2? Give me just 2. Did the thing. I wonder if I just clicked this button by accident, basically, and made those forever. Which is probably functionality I would actually be okay with leaving. Just to test. I want to say I did 22. Give me 22. Are you good on copper? You're good on copper. Okay. What's your problem? Got any problems? Are we cool? gonna feed it some something. Oh, is that even going in the right spot? Let's see. I wanted this to go to the pipe bender, which is 3. Okay. Give me 3. So I think the issue here was when it ran out, we had troubles. Now it got to the idle state and it was still locked, so that one line of code should fix that. Okay. That's all good, that's all working. Let's go ahead and craft something. Craft something till you can't craft any more of it. Maybe some of the insulated pipes would be good. Give me steel and silicon. Oh, that's the wrong spot. Whoops. Or no, still going here. We're good. Okay, so craft me more than you can make. You can make 50 of these. Give me 100. Go. Gonna set you up for failure and see what happens. You're a good breathy boy. Calm your breathing. You're stressing me out. Alright. That is crafting. That's doing its job. I think things are working for the most part. That's 12? Didn't I tell you to make 22? And you made 12? That's not right. Suspect. You're still misbehaving. Give me 11. Got enough copper? Yeah. Is there something off with the timings? Yeah, I missed one. It's missing a bunch of them. What's your deal? Do you take more than 3 seconds to empty? How are you doing? You counting down correctly? 72 remaining. 71 remaining. With 30 left. I think this is right. Alright, you seem suspect. You're being weird. It seems like the number is counting down faster. So we've got this one's tracking the stage. Stages seem to be working okay. Maybe different items have like different production times. This guy builds cables slowly. Maybe it also like releases them slowly. Maybe it like affects the animation somehow. Because it seems like 3 seconds has been enough for everything that's built here. But it's not being enough here. But anyway, I was saying that we have the stage console set up for the other one. Let's do the region count. Or item count, I mean, for this guy. See what it's thinking internally. So I'm gonna throw down our computer and put in the chip and edit you. Nope, edit you. You get to be the debug item count dude. Which is gonna put the item count in the item count console, and then you get to be debug item count. Okay. Zero is correct. 1 is correct. 11 is correct. 111 is correct. 11. Cable. Go. not going down. $11 forever. Oh, yes. I just clicked the button, didn't I? I keep doing that. Oh, whoa. 39, 10, 38. 9. You're fighting. You are fighting, aren't you? Hey, you're making things complicated here, and I don't want to turn you off. This one's fighting that one. This one still has comments. Okay. But you were counting down. You should be done by now, right? Yeah, you're still making things. Last one. What happens when you break? We have 25 left. I don't think that's right. You're still just counting down. Interesting. So it doesn't realize that it's not working. And then when it does another loop, the completion percentage hasn't changed. So it throws in an order to make a thing, and the completion percentage is still locked at 1 because it never started making a thing. So after a couple seconds, this thing just iterates and it'll just count down all the way to 0 and then cancel. Or I can cancel it now. Okay. What do I want to do for that? Do I want to like track that internally? Track the last completion? If it was 1, then recognize that it's wrong. It didn't start. That could work. That feels gross. Maybe I just want to feed it enough stuff that it never has issues. If it does, I can run up and cancel it. I think it's working okay. Especially if I can force cancel it. Ooh, that's not good. Don't make things. What you doing? Force cancel didn't shut it off. These should have been set to 0 by the cancel functionality. Let's take a look. Import, edit. Stop fighting with the other dude, please, thank you. Let's see. So it thinks it's in the crafting stage, maybe. No, I'm not sure about that. Oh no, it comes up at 8, or it comes out at 8 a.m. Thank you for letting me know. I thought it came out at midnight. I don't know how I got that in my head. Damn, well I've been up for a few hours then. That's all good. I was hoping to spend like the whole day doing it. It's gonna be fun. Gonna play a bunch of Battlefield 6, do a bunch of helicopter. Alright, what's going on here? What's happening? We're getting stuck in a weird stage. You display the stage, right? So you're in 1. Stage 1 is our idle stage. We should unlock the crafter. When we go to cancel, maybe we should also clear memory. Maybe that has something to do with it. Let's try clearing memory here. D crafter. Okay. Comment both these out. Overwrite that. Okay, and then I think I still want to track the stage for you. So let's do this. Export, throw this in. Edit. Export. Export. And then you still show the item count. Alright, I think we're still getting close here. Still debugging. Still close. Both are true. Food and water look good. Speaking of water, how is the water? 934 liters. Keeps climbing. That's good to see. Okay. So, I was thinking getting these to cancel properly. Doesn't look like it's happening right now. Or at least it didn't last time. So you should fail, right? You can't do anything. You can't make that. So you're in stage 2. Stage 2 is our... Let's switch the code in case we play with this thing. Stage 2 is our stage crafting. Okay, so we're in stage crafting. And the cancel switch is not on. The ratio is less than 1. So it keeps looping. Yeah. It thinks it's crafting when it's not. Is that true? What's your internal state for the completion ratio? What's going on here? How are we getting locked in stage 2? What are you thinking, guy? Completion ratio is 48% complete. What? Okay. So heading into stage crafting. Stage 2. Let's see, it's checking for the run switch to see if it should change the stage to the cancel stage. It's skipping that. It's saying if the completion ratio is less than 1, go to main. And then it's just doing that over and over and over and over forever and ever and ever. Amen. So what do we want to do about that? Maybe nothing. We want to feed it enough materials that this will never be a problem. And if it ever gets in a funny state, I want to be able to just turn it off and have everything reset like this. That's fine. Okay. I don't think this really needs any change. Seems like that's working okay. Alright, now what's your deal? What are you thinking, dude? You can't... I'm asking for 11, and you can't give me 11? Or something? Let's test that out. And I think I'm going to even move this console. Debug state... or debug stage can go here. I name you debug stage. Confirm. I throw memory chip. in you. Edit. No more stage. No more item count? Sure. Okay, so this isn't attached to any sort of visuals anymore. You get imported and edited. You now affect the stage too. Then you still have everything you need. I think it's good. I think I just added idle unlocking the thing. Is that a problem? This might be a problem. This is gonna set the lock to 0. And then it's gonna set it to 1, possibly, right away, without any sort of time to wait. Maybe we don't do this here. It should happen in stage cancel, right? That should be unlocking it. Yeah, it is. This should be all we need. We can just deliberately cancel it. Okay. I think we want to do this. We're going to break the lock functionality or cause some funny bugs. That's a little obnoxious, but sure. Let's overwrite our code. Let's confirm. Export it on all of these again. 2 to go. Why am I holding a drill? Okay. And then I want you to show your debug data. So we edit you and tell you to affect the consoles so that we can see what you're thinking. We should be able to see the stage here and the item count here. Alright, show me 11. Stage 1. You can make 11 of the cables, no problem. Make me 11 cables. What happens? This is going down fast. Is the completion ratio still just chilling at 1? What are you doing? I think it has to do with the completion ratio sitting at 1. It's staying there a little longer than expected. So I think it's doing another like lap on the loop and seeing that the completion's done and decrementing early. I think. Let's see how many of these it's gonna spit out. 7. Not 11. Still closer. Alright, let's take a look. I think we might just want to give it a single second right here. When you call the execute recipe, it doesn't go right away. It takes a second to think about it. And in that 1 second, we're doing another lap on our loop. And we're decrementing the number incorrectly. What if we literally sleep for 1 second? Does this do it? Not if we don't export. Alright, give me 11 cables. 1, 1, go. I eat potato while it thinks. It's 11. It goes to 11. Look. 11. Wow. I've never been so happy to see 11 before. Not even since Stranger Things. Nice. I think we're good. I think that's handling the corner cases. Only issue right now, debatable issue, is that when it reaches, if it runs out of material, it'll stay in like a locked state, but you can just flip the handle to cancel it and it'll wipe everything to 0. So that's not a huge issue. That's definitely not like that's not a problem where you have to like dig something up or reset it or anything. It's just flip the switch, flip the cancel, shut it off, cancel that job. You ran out of stuff. So not a huge problem there. I'm thinking this looks good. Let's go ahead and comment this out. This is the second or third time I've thought this looks good, but it's looking more gooder now. So let's give that code out and maybe even return the floor. That's a little cocky. I don't know. That's a pretty cocky maneuver. Okay. Boom! We did it! Unless we didn't. Last time we didn't, but maybe this time we did it. Maybe. I'm feeling pretty good about this. At the very least, I'm confident at this point that it is a solvable problem. We'll get there. If we haven't already got there, maybe there's 1 or 2 more bugs. But this is getting super close to exactly what I was hoping for. It's working nicely. So we do like 999 or something if you want to. Just make like a ton of shoots or whatever. And you just cancel when I can't do that. All resets. Okay. That's all good. What next? I'm tempted to take a shot at the mall automation for requesting stuff. Also, these have all been wired, so we should change the names to just things like run ones. Just make the labels a little nicer if we're ever looking at the ground to like check. Like, oh hey, what's this dial? 10s instead of 10s electric in all caps. I don't need to get yelled at. I just need 100s. Let me know. So let's just do a little cleanup. And this doesn't affect the wiring. Okay. Looking good. Mall automation continues. That was... That's so much work to just be able to click the button without accidentally draining the entire bank. It's a pretty worthy goal, though. Now we can click the button without accidentally draining the entire bank. If we set up some autofilling for resources. Alright, what does that look like, autofilling for resources? Let's take a look at the pipe bender as an example. And we can look at the internal memory. We've got execute recipe. We've played with that, and that's working pretty well. And that was good for learning. We can also just like copy paste that code and tweak it for the next thing. But we are looking for missing recipe regent, maybe. Is this it? It's got an opcode, which is opcode 9 to specify just the operation. I think quantity seal is quantity sealing, which could be up to like 255. So maybe we do a quantity seal of like 250 and see how much do you need to get to 250. And then it's got a regent hash for whatever the region is. This is just the integer 32 hash code for whatever the region is, so like iron or steel or whatever. And these are from addresses 54 to 62. Just trying to think, is this something we set or something we read? Can I just do like a monitor? What do you have along the lines of show me the amount of regents? So I'm just thinking how this could work. It could work like this. So I think the missing regents is just like a stack of, well, I don't know, we have to look into the memory and actually see what's going on here. But I think it's just like a stack from 54 to 62 where it's letting you know anything is missing if you're like trying to craft a recipe that it can't craft. So we could use this. You could just put in a recipe, and if it needs something, it's going to immediately demand it. If you're building something and it runs out, then we could have it just kind of wait while recipes get shot through the, or sorry, while the regent hash gets shot through the tubes, and then it would resume as soon as it's reloaded. So it might add small interruptions. And none of this is as good. I would love to be able to just like iterate through all of the regents possible in the machine and just see if we're looking for a target ceiling of like 200, how short are you of 200? And then we could just try and constantly keep it topped off more or less at 200. If it is anywhere below 200, we just deliberately add 100 more or 200 more. Just keep it overflowing. And then it would never have to like have a hang up where it runs out of regents and asks for more. That's going to slow down efficiency. If you're trying to make like a billion of something, then it's going to make 50 at a time. Or even for, if you're doing like a big recipe, it's going to, if you're doing like a large battery or one of the vending machines, they take like 50 gold each. It's going to have to get 50 gold and then 50 electrum and then 50 of this and 50 of that. Like every single iteration, it's going to hang up and have to have a specialized delivery. I mean, if it works, I feel like that's worth it just for the automation. But, gross. Gross. That might be the compromise of a solution that we have to do there to make that work. I am getting ahead of myself just a bit though. I think we want to add maybe some consoles and see if we can like read that. I want to just see some explicit values and see what exactly is going on in that memory section. I assume that's something we read, not something we set. And I could be wrong. So that's the thing to do. I want to look at my beautiful water. How's my beautiful water? Wow, almost 1,000 liters. At 1,000 liters, we can fill a 1x1 and make a swimming pool. That's the dream. I was thinking it'd be fun right on like the landing pad if we chopped up that 1v1 and replaced it with the pool with the glass ceiling and then a light below it. That would be fun. I don't know if there's room though. I don't think so. Alright, let's see. I think this is looking good. I do need to test. We'll have to like test these working with each other. Running out of material and requesting more, and then having it resume functionality. Or we'll see if it keeps like incorrectly ticking down and have to add a couple lines of logic to prevent that, but I think we can solve that pretty easy. Alright, I need to use the bathroom. I'm gonna stand in the corner. Oh, and we're out of food too. It's time to start cooking our own potatoes. I think I'm out of all delicious foods. The only things we have are potatoes. Okay. So I'm gonna use the bathroom. I might spend a couple minutes doing that. We should probably clean this up just a little bit. This could be less. And we could hide the pipes. And then we should move the fridge and add a little potato cooker. Because that's gonna be our food now. So let's do a teeny bit of cleanup and then maybe a little bit of programming. Back in just a minute. Alright. How are we doing? Better than ever. With every passing moment, my power grows. I really have been enjoying this save. This is a fun save. It's a fun game. Alright, so let's move the liquid pipe. That's a good place to start. We just route that up and over. Is that going to go through any pipes or anything? I don't think so. That looks fine. Let's start with that. Rip off some walls. Okay. Let's see, so this whole sky thing is basically just a remnant of when we started the save. This used to be the ceiling of our initial little like 2x1 or 3x1. The little emergency survival shack or whatever you want to call it. Okay, the water goes here, so this needs to be connected. I think we just go up through the ceiling, basically. T-Rex so cool. Look at me, I'm a T-Rex. Wow. Okay, this just needs to go up. Give it just a little room here. That is connecting with the main line. Okay. Needs one here, debatably. I was thinking we should pull most of these up. We really don't need this many. This is just potatoes now. It was, once upon a time, this was our entire air supply. Now it's just a couple potatoes. I think we can get rid of most of these. Just clean up some space. Alright, how many potatoes do I need? That's probably a fair number of potatoes. And then we can get rid of this light too. Clean up. What's your problem? Water? Alright, you should be good now. Let's double check. I'm going to take a quick look at the water supply in this pipe. 940 liters, that's the main water supply. All good. Okay, so that has been adjusted. We no longer have flying pipe. Let's change the flying wire. This can go. Okay. It's pretty crazy how much the oxygen machine is running here. Having to pull oxygen out of this air. Ferns do good work. Alright, so that is cleaned up a bit. I was thinking this should get cleaned up too. This looks gross for no reason. Let's go ahead and adjust it real quick. Get rid of these. You go here is good. Yeah. You vent this way. You are labeled CO2 vent. Oops. CO2 vent. Okay. We reprogram this guy, turn it off first. Filtration vent, CO2 vent. No, it's not plugged in, my bad. Not gonna find it, no matter how many times I click. There we go. Then it needs CO2. Okay, there we go. This is just the intake vent for CO2. This pumps CO2 into the room to maintain a minimum percentage. 65%. What are we looking for? Filtration vent is not a grow light. It is the CO2 vent. There we go. Now I turn that on and everything should work, and you should probably start running soon. We'll see. We can check later. We're pretty confident that's gonna work. Let's see. You should be purple. It's gonna help you blend in. You could even be purple. What else do we have to clean up? That's looking cleaned up a little bit. Alright. Potato farm shrinks. What else? This is just floating out in the middle of everything. A little obnoxious. You go hide in the corner. I need you. Smooth fridge. Where do you want to live, fridge? That's like right here. Like right here would be perfect. Why can't you live right here? You can. Right here. Perfect, right next to the water. Okay. You are the cable clippers. Go here. Does that work? There we go. Okay. Now most of this doesn't need. Oh, my eggs. I thought I spilled my eggs. You're good eggs. These should be in the fridge. All these water bottles we don't really need anymore. I'm tempted to just like throw these into space or something. I don't know if we're ever gonna sell them or what. But they are no longer valuable. I'm just gonna put them over here, I guess. It's gonna be the corner of sad water bottles. Let's forget they exist. We are very water positive now. Like 1,000 liters. It's time to start making waterfalls and pools. I want to see with the lighting what it'd look like to do like lights going through a water block. Would be cool. Lit pools is not a bad idea. Alright, what else we got? I wanted to, just while I'm beautifying a little, I wanted to do another light or two. I was thinking one right here. And then maybe one right here. Just kind of keep with the pattern a little bit. And those were shitty brown, I remember. So we whip out shitty brown. Paint them. Turn them on, plug them in. Alright, looking better. Everything's moved. What else? What are we missing here? No, I don't like that. Whoops. Pipe in the window. I guess that's okay. That's a little gross. My bad. What are we missing? The ability to cook potatoes. Probably should plant a couple more potatoes, too. I'm gonna grab these dudes since they're old, near expired. Let's turn them into new potatoes. Alright, but I need a microwave on the table, basically, I think. Might want to move this guy. Or even move this. It'd almost be better if the microwave was like right here. Just be a super small area. But yeah, I'm gonna start starving here. It's time to start cooking food. You should be pink too. You're purple as well. Can hide you in the wall a little. That's looking better. Okay. So give me a table? Is it like a desk? Desk? No. I would expect it to be electric. Maybe it's in the auto lathe. Table. Okay, give me one of these. You need iron. Okay, we're getting there. Let me store the potatoes real quick. Into the fridge with you. You're our only food. Iron go, auto lathe. Auto lathe is 2. Change that to 2. Iron go, auto lathe. I think we only need 1. Let's test you out. Go to 1. Turn it on. Locks up, does the thing, makes the thing. Poops the thing. You can pull the chute. You done? Turns the switch off, pulls the chute. This goes to 0. It's raining tables. Okay, that seems like it's working alright. Microwave. Microwave. I need 2 of these. So we do 2. Okay, that's gonna craft. Table goes like here would be good. Here would be good. You kind of gotta go. You're a little in the way. You're also in the way. On second thought, we want one of these near the front door. We should do nitrogen freezing someday, just so that I can go outside without a suit, because I keep doing that. And then we could panic, run into here before we die. We should put it just far enough away that I have to, like, I could, like, barely make it. I should be at, like, 40% consciousness when I reach it. If I make it hurt, maybe I'll learn my lesson. What's up, microwave? Alright, let's see. Where should the table go? Something like this might be okay, too. I don't think we want it by the water. It's gonna be obnoxious. I feel like I want it right here. Or right here is too perfect. I think I might have to move this guy. Yeah, that's where it goes. How can I argue with that? Hey, come on now. Alright, let's take a look. What's it take to move you? You are a simple filtration device with a small amount of programming. And you probably belong in the greenhouse. It's the appropriate spot for managing all of the gases, basically. Okay, let's clean that up real quick. That should be super fast. We just moved this dude real fast. So, let's see. I think I'm going to move all of the logic we have here for handling air. I'm going to save just in case this goes horribly wrong. But we shouldn't need to do very much at all. Just move stuff, quite literally. Take this guy. Alright, that's a start. Let's see. So we're just going to move all of that to the greenhouse and pull it off of the circuit that we're using for our cooling system. This line's not really being used for anything right now. That'd be a good one to handle. We've already got a gas sensor. This one can also handle air. That's not much to add to it. Don't need gas sensor. Let's see what's going on here. That goes there. Okay, and do I want to put that like in the corner? Let's just make some room. How are we doing? Snooze ads? Can't snooze ads. No ads for a bit though, we're good. Okay, so we need to set up the automation here. And we need to set up the gas management. Do I want to do the corner? Do I care? I don't think I care. I think right here is just fine. So let's give it the 2 housings and the 2 chips. Let's route power from the existing line. Should be right around the corner, no problem. Alright, these have power, they break immediately. They need to be programmed. You don't break? No, you don't break. You're the... what are you? Let's investigate. You are... no device, no device. Import, edit. What do you do? What's your brain? Show me your brain. Oh fuck, you do the grow lights. You don't live here. You kill our plants on accident. Okay, so this one stays. You stay. Yeah, let's put it here, it's fine. I was thinking it was multiple circuits, it's just the one. It used to be 2. We used to have AC, but we don't anymore. And that cable should definitely get out of the way here, that's gross. Okay. just worried about what's gonna happen to you. Oh, where did the oxygen things go? They got deleted. That's fucked up. I wonder if it's gonna explode with oxygen things. I hope so. There they are. Close one. Alright, just doing some cleanup. Grabbing the stuff and the things. Almost done. Put that there for a moment. Okay, so over here we can have our oxygen filter. Where are you? Atmospheric somewhere. Put it in here. Here.
Hunger critical.
Uh-oh. Bro's hungry. Now it's a race. Okay, so this is filtration. Filtration can go here. Should be okay. Let's try and get it basically in the corner as much as we can. Just put it out of the way. Screwdriver and cable. That's not a screwdriver, actually. Okay, there's our filtration device. Filtration device is programmed with this chip. Which, does this require anything? I think this has a D1 for an active vent. Let's take a look at you. What's your brain look like? Where's my laptop? Did I just leave it on the floor in a different room or something? I think I left it on the floor. Can't recall. I wanted to leave you on the floor. You can just go right here. There it is. Left it on the floor right next to me. Perfect. What's your code look like? Nope. This is... No. This just detects if the pressure on the input is high, and if it is, then it turns on and pushes to the output. So this is just like run at minimum pressure. It needs nothing except itself. So this one is fine. The input pressure is going to come from this guy. That's what tells the active vent to turn on. Now where's the other oxygen thing? Did I lose it? Feels like I lost it. Alright, I need to make another oxygen thing. Not a bad problem to have. So this is going to connect with some insulated pipes. Can we go up from here? Is there something in the way? There is. There's a water pipe in the way. I think we might want to reroute that water pipe to be a little lower. If it was one tile down, it gets out of the way. At the very least, we could adjust it right here, but like the whole thing could move. And it would only be helpful. I think I'll just adjust it in the couple spots we need to and call it good. Anyway, can't do the pipe for now, but we can do the wiring. And how's food? 2%? I'm gonna need to go out and eat before I die. This guy runs over to this circuit. That gives it access to... I mean, it just gives it power. But this wire now has access to gas sensors, which we can use to drive our logic for a vent over here. Okay. think we can still make pretty much all of it. So we'll have a vent that comes down, connects there when the water's not in the way. Can adjust that in a minute. Can I adjust that now? Can I just do that through the wall? Let's see. If I go funny angle, do I stick my head outside? No. Cable's in the way maybe? I'll just fly around and do it when it's not storming. Anyway. This will come in here. And it will be loaded by an active vent right here. Nope, that's in the way. Active vent go here. Should be fine. Direction inward. Name it. Intake vent. Alright, plug it in. And this guy has... little pipe here. I should probably do like an inline storage tank maybe. Doesn't matter. I mean, I could even just do more pipe. Just want to give it a little bit of like a reservoir. If we do something like this, this gives it more square footage. It's like it's a little bit of a buffer without getting one of the balls that's gonna poke out of the wall and look gross. So it should look a little better. Alright, don't need to look at any code. This looks good. This is colored brown. This is colored green? Brown? We need one CO2 vent, or CO2 filter. And we need to reroute that water a little bit. Are you brown? No, you were green. I'm sure of it. Like that. Okay. Dude's dying. Dude gets upset when he's dying. Have we made space? Do we have technology for the potatoes? We're getting there. What did I just do? Did I just break something? Did I just not complete? Yes, I did break something. What did I grab? What is this? A liquid drain. Oh, yeah. We shouldn't need this. But, there it is. I remember this. So if there's any pollution in the world, and we plug it into the tube, if it gets pressurized, it's gonna condense, and that'll squirt it out again. There shouldn't be much pollution, but there's been enough in the past that I had to do that, or break pipes. Alright, where is my foodstuffs? We wanted to do a table, like right here, ideally. Might need to adjust some cables for that, or adjust the flooring a bit, like right there would be great. I think that's the cable in the way. Anything else? That air tube?
Hydration critical.
I'm working on it. And drink. You can drink. Pretend it's food.
Health low.
70%. I mean, I can just eat a potato, but let's finish this first. Alright, I want to move the cable. Where's my clippers? Come on now. How is it so easy to lose everything? Amazing. There they are. Okay. X-ray goggles say clusterfuck. Mostly. I think we can do a connection right here. Now this goes around, and this section can get deleted without causing anything to break. Gonna need to pull that up. Okay, looking good. What is this? Fine. Alright, Breathy Boy, it's almost time to eat food. Can you say potato? Right there, seems good. The pipe gets pulled up. Got another one there. Another one there. Where is my microwaves? Microwave go here. Microwave go here. Wrench tool will attach them. Okay, almost done. Throw some power in the line. Turn that on, turn that on. Okay. Gotta return the walls, because I gotta. What are you? Oh, you're the lights for the potatoes. You're really important. And you're not working? Come on. That's not good. Okay, let's start with potatoes. Let's start with eating the potatoes, then we can graduate to growing the potatoes. You working? Did I put an oxygen thing in you? No, you don't cook the oxygen thing. Alright, well, we found the oxygen thing. Alright, first baked potato. I think this is the first self-grown meal. We did it. We're potato farmers now, and we got a fridge. And I can cook a couple more. And it makes a nice whirry sound. And a satisfying ding. Amazing. What a game. It'd be good to automate better food production later, but for now, this is just fine. This will keep us alive indefinitely as long as our grow lights work and our potatoes keep growing, which doesn't look like that's happening right now. So let's take a quick look. What's going on here? You are a very straightforward program that we have used many times. Device is null at line 6. 6 is saying SB lights on 1. Okay. Device is null. Does that mean the circuit is not connected properly? Looks like it is connected to the grow lights. Yeah, you look like grow lights. That's a cable. That's a cable. Is it because it's purple? I would be amazed if purple has anything to do with this. It shouldn't. We can double check too. Let's look at the most sure way is to look at the network analyzer and say, alright, what is your network? You are in the 550060. 550060. They're on the same network. It's got power. If we edit, this is just the lights structure grow lights. Set batch lights on 1. I'm very surprised to see this. Device list null. Oh. I see. My bad. I understand. I'm learning. I built the wrong version of this. It's got the power connection up top, but it doesn't have data. I need to do this one. That shares. Then it goes. My bad. Alright, You grow potatoes now? You guys are thriving? Everybody's happy? Food supply is gonna keep going. Got a fridge where I can store potatoes. And then the only thing here is that these are pretty low quality, so it's not amazing. It's gonna bring the water down. You see, it's not thirsty. You can't drink anymore. It's gonna be like 100 now, so we'll have to go to the water fountain more often. Not a great food, but that's okay. Alright, let's see. So this area is looking much better now. I think pretty much all the remnants of our starter cube have been cleaned up. Need to get the air filtration done. It's still broken right now. But just in general, a little food station here. This is nice. We can grow potatoes and throw them in the fridge, drink water whenever. Infinite food and water. Tucked into the corner by the entrance. I like it. That's looking a lot better. It took like days. Been slowly picking away at cleaning up this area for a very long time. Alright, ceiling looks good. Just got too many claddings. Throw some in the wall. Okay, what are we doing? Cleanup and... let's move the air filtration. That's a very, very important thing that's not working right now. Let's get air filtration done. You go here. I will store you. Okay. So this needed the water adjusted to be out of the way. And then we also need to bring the carbon dioxide line. No? Maybe? Should I leave this? Tempted to leave this. It'll need programming. But we could program that very easily. And I'm gonna move it. Let's keep all the air stuff in the exact same location. CO2 vent go here. Alright. CO2 vent go here. Then all the logic will keep up with exactly what it's done in the past without needing any sort of thinking or reconfiguration. And that further kind of cleans up the main hab. So I think this is better. Let's plug you in. Let's name you CO2 vent. You stay as outwards. You are inwards for intake CO2. Okay, looks good. That's fine. I move some pipe. And I paint you green. I don't know about you, Floor. I'm gonna leave you brown for now. Alright, time to reroute some pipes real quick.
Oxygen critical.
We need the oxygen pipe to go up there. We're going to filter the oxygen out and into the oxygen pipe, which is already very close. We can just bring this one up. We need the carbon dioxide, this guy, to extend over to here. That's not so bad either. And then I wanted to just adjust these pipes only a little, I think. I don't need to do a lot here. Let's move just a few of them and call it good. Where is my wrench? Wrench. Where is my wrench? Where's my wrench? Hopefully not on the ground somewhere. Okay. Let's adjust the pipes. That's enough. I need very little here. I can double check. That might not be the right spot, actually. This is the wrong corner. Let's do the same thing on the other side. Let's save real quick in case we break out the wrong thing and start a gigantic fire in our base. Alright, how's this? That should be out of the way. Okay. Let me change the music real quick. Oops. One moment. There was a good piano one. Where's the good piano one? This one's good. Okay. We can double check. We can see the pipes here. We could even add a pipe right here. So this is that intake for our filtration, and then oxygen comes out on this side, perhaps. So let's route oxygen over to here. That's a place to start. Need oxygen, need carbon dioxide. Let's take one quick look at that again. Where's this coming out? It's in there. We can't craft it through the wall, but we can decide that this is coming out right here. Should be fine. So let's connect this guy to the oxygen line. And we should be good. Something like that. You go up. Need a wrench. Just trying to rotate. Come on now. No? Can I not rotate this? We should be able to do one right here. Should be able to do a long 10-1 right here. That looks good. Okay. Saves a few clicks. What about a 5? Looking closer. Down to 1. Need more pipe or no? Something in the way. Tricky. Also, X-ray's not helpful here. Hold more still. Jetpack, please. I'm gonna stand on pipes. That's better. Okay. There is that. What about the CO2? CO2 should probably be like over here. We can just move the active vent without a problem, but let's try and line it up more with where the CO2 is actually coming from. This guy can route along the wall as well. That's the wrong color, my bad. Swap those. Grab that, change the color. Rotate. Rotate, dude. There we go. Alright, let's go ahead and curve out from here. Just go one over and then up. Alright, that's a better spot. Going to the wall from here. Oh, it's right into the icy housing? Okay, maybe not there. How's that? Okay. We're home. Full jetpack. Eat a nice, delicious potato. Drink water. Can't check water anymore. The tube's hidden. Could be good to do like, we could compute the percentage of how full it is and just write that to a console or something. Or we could just ignore it, or we could look at it right here, I think. Can I look at it right here, maybe? I think we can. Perfect. Up to almost 1,000 liters. I feel like we need to throw a party to 1,000 liters. That's pretty nice for Vulcan. 999. Ooh, that's almost 1,000. We're doing good. And how's the air in here? We're down to 62% carbon dioxide with no change in pressure because it's a 1-to-1 change from CO2 to O2. Okay. Well then, where were we? Let's finish the air. Okay. This guy needs to get out of the way. This needs to be brown. Gross. You are the CO2 vent. Okay, you get moved. CO2 vent live here. Yeah? One lower. That's fine. We'll do that. CO2 vent. You are intake. Yep. Power go here. Okay. Save just in case. Turn this on, should break immediately. We need the filtration device? No, that's a filtration vent. I don't like that name. Import, edit. Filtration vent. Should be like intake vent. The intake vent. The intake vent. The intake vent. The CO2 vent. The intake vent. The intake vent. Cleaner. Should I save that? It's atmospheric something? Filtration? Atmo collector? I'm scared to overwrite any of these. We're gonna confirm, we're gonna export. We're gonna throw it there. It's gonna break again. Alright, you are the intake vent, which is the intake vent. You are the CO2 vent, CO2 vent. Gas room sensor is the gas sensor. That should be it. Save game, but this should start working now. Should bring in CO2 since CO2 is low. Pressure should get high, so that should start taking stuff in. And then you cannot work. Let's turn this off. Off. Okay. closer. Need oxygen to be able to go somewhere. Alright, that's turning on. You plug into the main oxygen supply. And that's working. Okay. So let's overwrite that code. What are you? Are you filtration? Are you the Atmo collector? What's the Atmo collector? Atmo collector is the outside Atmo collector. Air filtration with vent. Yeah, this is the one, isn't it? Gross. No. Filtration? What is this called? It should be like atmosphere management or something. Hab air manager. Seems right. This is the one. Okay. So we're gonna turn this off, turn this off, turn this off.
Oxygen low.
Oh, that's not good. What the fuck? Are we fine? We're fine. We just got a lot of pressure in here, I guess. Let's check that. CO2 is just above 65, so you should be turning off by now. Anyway. I wanted to overwrite the code here. I'm gonna import this. I liked this code more. We changed it to intake vent. Okay, so we overwrite our hab manager. Where is the hab manager? Hab air manager gets overwritten. Export that. Put it back. Were you... This seems wrong. We should be doing no more CO2. Right? Oh, we should be doing more CO2. Interesting. It's still not up to 65. Okay, you're working. Everything's fine. Do your thing. We didn't have working atmospherics for a long time, so O2 piled up. Alright, now this should dump CO2 until we hit 65 around here. And then that's just going to equalize with everything over time. But I'm pretty certain this is all working. We've seen it working before plenty. It's just, yeah, there it is. Good. And this is pulling down to 65. How's the input? 18.5 megapascals. 19 megapascals. That's a little sketchy. I mean, this is doing the one-time job of the massive build-up. I think we're okay. I think it's generally going to be a lot lower than that. Alright, so I think everything's working. We're pumping out all the oxygen that we grew while we were doing some construction. Return the walls to their original place. And yeah, that's good. Okay. I think the only thing might be double check nothing explodes here. Maybe add a little inline storage container. But I don't think we do anything. I think it's good. 4 megapascals, or 0.4 megapascals to go. Alright, what are we doing? What's happening? Eat a potato? How's my potatoes? Thriving. Beautiful. Eat a potato. We're now potato men. Potato people, really. I didn't paint this. What color for you? I like black more. Can I paint these? Ooh. Interesting. Where did my white spray paint go? Right here. So they can blend in a little. That looks nice. Looking better. How we doing? What time is it? 4 a.m.? 4 hours in? I think I do want purple. You be purple. You be purple, you be purple. Alright, 4 hours in. What do we do? We programmed the automation for the buttons on the mall, which seems to be working more or less correctly. Now we can control how many of things we want to make, and then if we keep these things auto-loaded with material, we should never need to manage the mall at all. We can just send stuff automatically, and then craft as many as we tell it to craft, so it's pretty much a little bit of a sandbox there. Just put in whatever you want, and it'll make it, and request whatever it needs. So we need to make the request system. That's gonna take a little bit of time, but shouldn't be too terribly different than what we've already done. That's good. Got the potato station all set up and cleaned up. That's the last of the remnants of the starter base. I'm liking that being done. This area is looking nice and clean. You need liquid nitrogen someday. Let's maybe make you something different. White's nice. Sure. Sure. Looks good. But we can eat potatoes forever. Water's still going up. Everything's looking good. 1,000 liters. 1,010. Looks good. Air filtration's moved over to here. Everything's just kind of looking a little nicer. I want to keep prioritizing. Like, making things look nice. This looks so much better. It feels like that matters. It's cool. It's just constantly nice. It improves my morale like I'm a dupe. Straight up. Alright. I think I might want to take a break for just a little bit. Just like stand up and walk around for a couple minutes. Getting sore. Maybe eat a couple bites of potato. And I think I might want to take a stab at doing the programming on requesting stuff. I'm excited to do that. That'll be fun. So I'm going to chill in the corner for a moment. It's a good time to run ads. I'm just going to walk around for a minute. Paint infused potatoes. It's perfect. What do we got? We can check the air. Oh, there's pollution. There's some paint. Yep, we're eating paint. Still probably better than what I eat in real life. Alright, I'm going to be back in a minute. I'm going to move around, run some ads, and then let's maybe do a little more programming. Food is good. Did some human things. Did a couple laps around the house. Gave Kitty some love. He's a good boy. Alright. Is it time? Is it time to do the auto mall? That's pretty crazy. Mountain Dew is good. Let's see. You excited for BF6? I am. One day. 28 hours, I've been told. Master Ninja told me the exact time. I was 8 hours off, which was pretty disappointing. 28 hours. And then we get to do some Battlefield. Alright, so let's take a stab at the mall. We've got these guys all set up nicely so that we can tell it how many things to do and it'll do that things. And then when it runs out of material, I want to write a program to check on all of our devices. And when they have run out of material, if they need something, like right now if we look at this guy, he needs steel and silicon to do this. So I think right now in his internal memory, if we take a look at values, we'll see that on the stack for required stuff, there should be 1 steel and 1 silicon. So I want to write a program that looks through these guys, looking at their stacks and checking, do you need anything? If they do need anything, then we can send stuff their way. And along with that, we'll also keep an eye on what's going on with the shoot dial. I want to leave, so this shoot dial, I want to be able to run up at any time and manually just be like this. I want to have control. I want to throw stuff. I also want, like, let's say the furnace is doing something. I want the furnace to take claim of this dial. But basically, I want to check to see if this is 0 in the idle state. Then, I want to be able to see that, like, okay, it's open right now. We have an opportunity. Let's move stuff through the chutes. So I can claim stuff if you want. Like the furnace can claim stuff and dump 1,000 ingots in there. I can run up and claim stuff and say, I want to drop stuff to the ground. And just dish some stuff onto the ground for fun. I'm gonna throw 1 thing of cobalt. I want that to drop and I want to just throw it into the sky. Or I want to feed it to a vendor. A vendor wants to buy cobalt. Sure. There we go. So like I can take control and drop things if I want. And then also anything on the line can take control. So the mall will be one of those. The mall will take control. It will send stuff to one of these devices, the pipe, tools, electro, or auto lathe. And then when it's done, it'll set itself to 0 so that will free up the line for anything else that might want to do anything, which could be me, or it could be more likely like the furnace. We'll have some code. So we'll have mall code for checking and distributing stuff, and then we'll have mall code for checking the values, probably, or maybe we even mix that into the same chip. But we need some sort of code for like checking, are these low at all, or any of these low? And if they are, then, well, none of these actually. Any of the craftables. If any of the craftables are low, we want to be able to send off a request to the furnace to craft something. And along with that, we can pipe through whatever it needs to fill the furnace. So a couple programs to write there. Not exactly sure how that's going to work out, but just kind of doing this one step at a time. First, getting these chutes controlled programmatically, plugging them in, writing a program to control the production of the everythings, and now writing a program to try and request resources when necessary, so that these guys are always ready to go and can make whatever you request, unless we're out of materials. Seems reasonable, seems doable, seems like it might be a lot. That's a lot of words. That's a lot of words to try and teach to a computer. Computers don't like to do what you say. They just do exactly what you say, but it's not what you said, though. We don't know about Little Bird yet. It sounds like they're going to release one. So that will be fun. I will play that if they do that. But what if they don't? They haven't given like 100% confirmation. They've pretty much implied that they're going to do it. So I would think unless like the game tanks or something, which doesn't seem likely. Probably going to see a Little Bird. That'll be nice. Not for a bit though. We'll see how long. Okay, so I want to program this thing. I think I want to start from scratch basically. Let's find my laptop. Is it on the ground again? It's been on the ground every time I've looked recently. I'm zooming. What's over here? Zoom, zoom, zoom. Are you on the ground over here? No? Are you working correctly? Yeah? Everything's cool? Everything's cool and the world's beautiful? It's good to hear. Where is my computer? Okay. Not a bad spot for it. Alright, so... where's my IC chip? In my hands. We're getting there. We have figured out how to put the IC chip into the computer. And now we can talk to it. Let's grab the starter template code. And start programming here. What's the goal of this game? Mostly to not die. This is a systems game. This is purely an engineering game. And you need to have air to breathe and food to eat and water to drink. We are very far along in this save. This is a super difficult planet. It's like very hot. Is its biggest thing. It's very hot and there's no air, there's no water. So you have to figure out how to make air and water when there's no air and there's no water. So got a huge cooling system set up that took days, and that cools off some gases, and we combine those with plants to make air and water. And then just make a big sustainable system. And now I'm into the end game here. I am trying to set up an auto mall for all of my resources so that the machines are smart enough to just demand whatever they need, and I can just craft stuff. Treat the game like a sandbox. And this is all tied into like automated production and furnacing and stuff as well. So specifically, it's all sort of engineering game, basically. A bunch of systems, a bunch of engineering, and a bunch of coding, which is what we're working on now. I got the whole thing on YouTube, basically. If you want to watch 1,000 hours of content with minimal clipping for ease of editing, not for ease of viewing, but for ease of editing. Anyway, let's get this going. We're gonna have AV stage. I believe we want to use stages for this. Could be wrong about that, but this seems to be a pattern that's working well for us so far. We'll have V stage. We will have our stages, which are going to be stage idle. Could be a start. That's going to be 1. Stage what? We have stage idle, and then we have like stage shooting. Filling. Do we even need stages here at all? We can just delete them. We'll see. We'll see if this comes in useful. So we'll default to stage idle. We'll make those constants. I don't think we're going to use those right now. What do we want to do here? We want to start, we just want to do an individual, like one-time check. Even is fine. And we want to output some stuff to consoles. We want to read into the memory and see what can we find and make sure that it's working as we're expecting. So that's where we're going to start. And then once that's working, we can work on making that more abstract and plugging into everything instead of just one. And I don't think that's going to be too hard. I think that's just like you give it a name hash and iterate through the stack. Something like that should work okay. Some sort of loop. Alright, that's a large tangent there. So let's see, what are we doing here? For our load variables, we're going to be checking our shoot value in particular, and then we want to be checking the values of the internal memory of whatever our target is. So let's go ahead and do that. We're going to want to have some variables ready to go. We've got our stage variable. We want to have the shoot setting. It's going to be our 14th register. We're going to have our internal memory. Maybe just v internal. Yeah, that's going to be the internal memory of the device that we're checking out. And then we'll have to iterate through those one way or another. But for now, we can just like hard code and go from there. Okay. So we'll have our shoot setting to read the shoot. We'll have our internal memory to read the internal memory of the thing. That's also going to lead to giving us hash codes in particular is the main thing that we're interested in. So v hash code. R12. Maybe like even internal hash code. Yeah. So we'll have internal hash code. And then I think we're going to have a device hash code. For... Let's take a look. If we're doing set by name, we're going to have a device hash and a name hash. Okay. So yeah, we're going to have a device hash. Let's delete the code. Make it a little bit smaller. And then we're going to have a... Let's see, we got an internal hash, we got a device hash. Is there anything else I was interested in there? We're going to have device name. It's probably going to be rotated through. And we got to make sure these registers aren't overlapping. I see 12 twice, 15, 14, 13, 12, 11, 10. Internal mem. I think you're right. I think that is better label. Thank you. Okay. So this should allow us to read internal state and figure out if there is an internal hash code. And then we're also going to need to keep track of the device hash. How can we get that? Maybe we like rotate through the D inputs. Maybe we put it as... We put it into the stack. Okay, I probably should just do that. We should get the stack going. Rather than just doing like a specific thing, just while I'm thinking about it. Alright, what do we have? So we have, for inputs, we have no inputs, really. We're going to pretty much be using explicitly hashes, but also the stack, which is going to contain hashes. So stack is just a stack of memory. You can think of it like a stack of cards. We haven't used it yet, and I haven't used the stack in this game in like a long time, if at all. I think I used it doing the Wally hand guy sky grabber that pulls your potatoes. I'm pretty sure I used a stack for that, and I also am pretty sure that I more or less chopped apart some example code that the devs gave. So it wasn't... I don't feel responsible for that stack. I stole that stack and chopped it apart. But anyway, I think we want to push stuff to the stack and then basically like rotate through the stack 2 items at a time, where we'll have one device hash and then one name hash. And so we can load those with every iteration and just kind of rotate through the whole stack. I think that is perhaps the way to do it. That seems good. So for this, we're going to want to push a hash with a name. What do we want to name it? Auto lathe makes sense. Something like this. And then push hash with an item hash. So the auto lathe is a hash of the auto lathe, which is the auto lathe structure. So we could basically like, we could either pop both of these off, or I think we don't ever push and pop stuff. I think we just use like a stack pointer to look wherever we're looking inside of the stack. And then we'll just like grab the first 2 things and then increment the stack pointer too. And keep doing that till we reach the end and rotate up. But we can pop off the item hash, the device hash, and we can pop off, or look at, not pop off, the structure. So sorry, this is the name hash, this is the structure hash. But if we just follow this pattern, we can do it for all of them. We can have the auto lathe, we can have the electronic printer, we can have the pipe dude, and we can have the tool dude. Electronic printer, pipe dude, pipe, Pepe bender. Nice. Tool manufacturer? What in the fucking name is tool manufacturing? Okay. Alright, and then we need to adjust for the actual hash codes here. Okay. Electronic printer hash code. Go here. Yeah, pipe bender. Pipe bender. Are you the upgraded one? I hope so. You look upgraded. Pipe bender is pipe bender. Okay, so auto lathe is structure auto lathe. Electronics printer is structure electronics printer. Pipe bender is structure hydraulic pipe bender. Tool manufacturing structure tool manufacturing. Okay. Now, does this actually line up with the names? What are you? Auto lathe. Hydraulic pipe bender. Your name sucks, dude. You should just be pipe bender. You're pipe bender now. Electronics printer. Tool manufacturing. Okay. So I think that's good. Looks like the names line up. And that's how we'll get the name for when we set by name. We'll have the item hash and the name as well. We'll be able to use those to target a specific thing. And we're also going to use that to read memory. Oh yeah, stack is powerful. I think stack is like the primary way of doing memory management if you're gonna like do any sort of array in particular or any sort of larger set of data. I don't know how the game works. Are there any intermediate stages? So we're figuring that out. I just kind of put down placeholders. We actually haven't done any logic yet. We're just making variables and talking through how this might work. I feel like defining the right variables and like data structures and stuff makes the solution fall into place pretty well. So that's kind of what we're setting up here. And this isn't exactly right. I think we'll have a few stages here and we'll walk through it and make them as we need them. I think we're getting pretty close at this point. Okay. So I think what we're going to do is now we can start moving along and actually writing the program. But I think we basically set all this state. And then that should be about all we need. If we can load the hash of whatever needs to be delivered and we know where it needs to be delivered to. Oh, maybe one more thing we need is in our stack structure, we have the targets of what names and what hashes we want to hit here, but we don't have the target of what shoot value we want to hit here. So that's something that we need to add as well, I think. Push hash. No. It's not going to be, it's just an integer value that we plug in. So what are these? Auto lathe is 2. Pipe is 3. Tool is 4. Come on now. Pipe is 3. Tool is 4. And I did that on the wrong line for 3. Pipe bender, push 3. Tool manufacturing, 2, 3, 4. So you must be 5. And then we'll double check that. And maybe even rearrange those. 2, 3, 4, 5. Electro's the last one. Okay. Electro, you move. Okay, so 3 variables. And then we'll have alias v target shoot. It's R9. So we're gonna pull that guy out too. Oh yeah, this game is by far the most interesting like programming game and problem solving game I've played. The assembly is awful for a lot of stuff, but for really basic systems like everything we're doing, you can get a lot done with some pretty simple small branching logic. So it's really fun automating away all the problems. You can get some crazy programs. This is some of the more advanced stuff I've taken a swing at. I've not written the last couple programs before. Everything today is new. So far, so good. Okay, so we have our values here. We've got all of this state that needs to be loaded. So let's go through the process of loading it, and then we start with the stage idle, and we have a stage filling. Okay. So first off, let's add the branching for the stages, I suppose. We can say branch if equal v staged, stage idle, go to stage idle. And then we need to make a function, stage idle, which is just jumping to main. But when we're in the idle stage, we go here. Otherwise, when we are in the filling stage, stage filling, we go to stage filling, etc., etc. Okay, so we can add as many stages as we need. We just need to walk through whatever process we have. Every iteration of the loop here, it's going to jump to load variables. So we're going to load a new set of variables to run our program on. Okay, so first off, let's just go through it in order. Let's load the shoot setting. What is our shoot setting going to be? It's going to be load by name into our shoot setting. Device hash is shoot, which doesn't exist. Define shoot as the hash of the dial. It's not a shoot at all, it's a dial. The setting is a shoot. Structure dial, okay. Where's my shoot? My shoot is a dial. So load the shoot setting. We should probably call that dial setting. Dial setting comes from dial. So it's any dial device named shoot dial, I think. And that should be hash. Your setting with the batch mode of 0, I think. What's 0? It doesn't matter. There should be none of them. So average is fine. There's only going to be 1. Yeah. So let's check this. First off, our variable's named wrong. It's not a shoot setting. It's a dial setting. Goes into R14. It is the dial hash code named shoot dial. What's your name? Shoot dial with a capital C, which is not what we have. Okay. So this should load the setting that we have on this dial. Because this is basically our like master control here for what we're allowing to have control over the whole system. This is how you kind of lay claim to managing the vending machines. So the first thing we want to do is check that's at 0. And we want to keep idling until that's the case, because there's nothing to do until this thing's available for use. Food and water. How you doing, potatoes? You look good. Should I replant you? With our new potato technology? We could teach a Wally to do potatoes. I want to go all out when we do Wally. I want to teach Wally to make chocolate bars, maybe a cake. Potatoes are just for staying alive in the beginning. They're a good place to be right now. This is a good use of time. And live forever. No effort. I am the Martian. Look at me go. Pick me, Elon Musk. Shoot me into space. Alright. Here's much food. Let's do a quick check too. How's the water? Water is 1,050 liters. Still going up. Alright, where were we? Loading variables. Okay. So we've got the dial setting, the internal memory, internal hash we can get, but only after we have these 3 variables. We need the device hash, the device name, and the target chute. And let's flip the order on these two to match the way they're pushed in. It goes name, structure, chute, name, hash, chute. Okay. 11, 10. It's a pretty minor detail. So yeah, let's load these. These come from wherever the stack pointer is, I suppose. Is the stack pointer? Can we just look at that? Can I just plus you? Can't I just peek? Isn't peek a thing? Let's see. We could just like pop. Not sure exactly how we want to interact with the stack here. Let's take a look at some stack commands, maybe. Tell me things about stack. I know we've got like peek and pop. Do we have any other commands around the S? I feel like there'd be some S commands for stack stuff. What can we see? Bunch of sets and... yeah, mostly setting. Shift left. Oh, sorry. Hope that hasn't been making noise for a while. My bad. Didn't hear it. Alright, I see nothing in... it's all storage. What can you tell me about SP? Nothing? Is there like a stack length that we can see? Should I specify that as like a constant in my code? All sorts of questions. We could have like we could say there are 1, 2, 3, 4 iterations here. So like we could have a hard-coded stack length of 4. Kind of gross. And then read the stack at whatever index we need there, based on how far that's iterated. I feel like that feels wrong. I feel like we should be moving the stack pointer every time we like peek at stuff, but then not popping anything off the stack ever, and just resetting it up to the top. Either that or we completely pop the stack till it's done, and then like reset it somewhere along the line so it can do the whole thing again. That could work too, perhaps. Not sure. I haven't messed with the stack too much. Stack's handy when you have a list of devices you want to process and can loop through them. Yeah, that's pretty much exactly what we're trying to do here. Go through these devices, doing basically the same functionality. Look at that internal memory at a specific spot. And then send it off to the right chute. Okay. Do we just need like a stack length variable? This feels gross. Feels like stack length should be a thing. I'm gonna talk to ChatGPT about it. I'm pretty sure that's a variable. Yeah. Oh no, ads are interrupting. I'm sorry. I'm just reading. Yeah, that makes sense. That's a good way to do it. That is basically what I'm doing here. So you know the answer. Backseat game me. I don't mind some help. We're getting close. We'll get it. But there's probably an elegant way to do this that would be good to be comfortable with, and is probably the easiest to comprehend when you're comfy with it. Let's see. Let's take a look at the internal state here and see what we can see. I think it might be located like in the memory. That would make sense. I should just type pipe vendor. There we go. So if we look at the variables, where's that API? Did I grab the right thing? I did, right? Where's my API? Holy. There it is. Is there anything here? There's a stack size. There we go. Okay. Nice. So we can load the stack size. Put that into R8. Stack size is load from self. Is it just like DB? Like that? Let me double check that. I'm looking at the wrong thing here. We're looking at like a housing, I think. Okay, so you can read your own stack size. Because that's what we're looking at, is our current housing. So I have to reference myself through DB to reference the housing that's holding the IC chip. So this is referencing the current IC chip, which should be referencing this stack size, I think. Okay. So we will say, we're going to load the stack size. We're going to say, can we set the stack pointer explicitly? Is that something that we can modify? Can I set a stack pointer? No. Ooh. Tragic. Each loop I'd pop 3 times to get the data. Should we be popping here? Popping seems easy. Should this be like... We could just pop it off until it's empty. And we could have a function for like set stack. This could all be a function. Could be a stage even. Or it could be a function. That makes sense. Let's see. How do we want to do that? I think I'm okay with doing it as a stage. That's not... we could do like a jaw function where we jump in, but then we're going to have to push and pop raw as well. Or we're going to lose that reference. I remember if you like call functions within functions, you have to manage raw pretty manually, the return address there. So maybe we just call it a stage, and then that's how we start. When you initialize the program, it's gonna start in that stage. So we could have a stage fill stack. Not super happy with this, but that'll work. And then all this needs to move. It's gonna be some clicks. I got some clicks to do. Not the best IDE, debatably. I really like it, it's pretty good. Not quite VS Code. Alright, remove code. Ooh, that's a lot of clicks. That's a lot more clicks than a drag. Almost done. Okay. Alright, so we have stage fill stack. Stage fill stack can be stage 1? Okay. 1, 2, 3. And we will start at stage fill stack. Stage fill stack. Fills the stack. And then it moves the V stage to be stage idle. Okay, so now it's a stage, which we are initializing our program to. So the first thing it's going to do, it's going to try and load variables. It's going to go to stage fill stack. It's going to fill the stack. And then after that, it's going to go to stage idle and jump into the idle loop now with the full stack. Okay. So then do we just like pop all these off every iteration? And if the stack size is 0, then we change our stage to fill stack and JMain. Something like that. I think we branch. We branch to fill stack, which is then going to go to stage idle and go to main. Just restart everything after filling the stack. Okay. Alright, so what are we doing here? We're loading our stack size from ourself. If the, let's see, if the stack size is greater than 0, then go ahead and jump 2 lines. There's something in the stack, so you're good to pop it off the stack. Otherwise, if the stack is less than or equal to 0, it's going to enter this line here, and we're just going to jump straight to stage fill stack. Stage fill stack is gonna... this doesn't need to be a stage, does it? Stage fill stack here can just be a function. It's gonna fill the stack, it's gonna change the stage to idle, it's gonna jump main and start looping. I don't think this needs to be a thing. We just need to call it before we start main. I think this is a little cleaner. Just a function. What is simplest? What is less? So we'll start in idle, we idle. We got idle and filling. And in fact, I don't even think we need to call this at all. We start in stage idle. Idle is gonna check and see that the stack size is empty. So it's going to immediately jump to stage fill stack, and then at this point it's ready to go, and with every lap it's going to be popping off the stack until the stack is empty, and then it reloads the stack. That seems okay. Not certain, can't recall what the cleanest way to handle this is, but that seems reasonable. So what are we going to do here? We've just pushed all this onto the stack, meaning the first thing we're going to pop off is going to be the last thing we pushed on top. It's like a stack of plates. You put them down, you grab the last one first. So it's going to pop this when we call pop, which is our stack size. So pop, stack size. And then we've got our item hash.
Hydration critical.
Pop, device hash. Then we've got our device name. Pop, device name. Okay. How we doing? We're doing it. It's a lot. There's a lot of things happening. There's a lot of things that are likely to break on us. And we haven't even really done anything yet. Just loading memory. Just loading. Just now getting to target the memory. Alright, how do I load your memory? Let's see. we're going to want to load the internal memory. And how do we do that? Oh, wise wizard ChatGPT. How do I load the internal memory of a device by hash? ChatGPT just made up the dumbest thing I've ever read. Let's see. It's got to be some kind of load, right? What's a nice, like, load memory where we've got... Oh, it might be slot index. Maybe. So we want to load memory. Loading a particular piece of memory would be fine too. That would even be better. Not sure what slot index is. What up, Taz? Moldy cheese day. Isn't all cheese moldy cheese? Pretty sure. That's how it becomes cheese. Looking to access it by item hash and name. Ooh, it says you can't do that. Ooh, that's messed up. Uh-oh. Alright, well, we have to, like, wire them in and loop through them. I think we can make that work. I don't think that's the end of the world. But it would be perfect if we could just access it, look at the memory based on the item hash and the name hash. That should be enough for, like, all the hash interactions. But they might not have that for loading. It looks like you can load all sorts of things, but not like the stack memory. Perhaps. I've got to use the bathroom real quick. I'll be back in just 1 second here. Probably should run ads too. Keep those from interrupting. Back in a moment. Let me, I'm gonna eat and drink first too. Oh, I canceled. Oh no. Did I lose anything? Did I lose everything? I lost a lot of clicks. Can I load? I'm terrified. I'm gonna save this real quick. I'm gonna try and load the last save and see if we can get the code back. This is the mall requester, mall manager. Mall manager seems okay. Alright, let's save that. Let's see what happens if I rewind a little bit. Is that gonna remember my code? I think it might. If not, I don't think we lost much. It's mostly thinking. It might be thinking in the wrong direction. It's a good attempt, but that might not be functionality that's available to us. How you doing? You got some stuff reset? That's okay. Alright, I'm gonna chill in the corner and use the bathroom. Let's keep working on that. Let's see. what to do, how to do this. I'm thinking we can tweak. Just the whole design has to be tweaked a little bit. We can't. Let's take a look at the code. I'm gonna take a look. So just trying to figure this out. It looks like, so this would have worked. This is a good idea. What I had written before is a good attempt, and it would work if we could load memory based on the item hash and the name. But it looks like that's not enough. So what I'm thinking is maybe we tweak this. So instead of rotating through all of these, we can rotate between some different integer values. Let's just do like an I loop that's based on the hash. And then we can use that to just base what we're going to do for where we're going to load our memory. And then we can have these things directly tied in as D0, 1, 2, 3. So that way we can actually target the memory of the devices. And we only have to branch for like one line of code for where we're loading that one piece of memory, and then everything else can just resume. So that should be pretty doable. Just a little bit of a refactor here. Should be able to get this working. So my bad, misunderstanding of what I could do. That'd be a nice function to be able to check out memory based on item hash and name. But it's not enough. So we are going to make our devices. We will have our D auto lathe, D0, alias D electronics, D1, alias D tools, D2, alias D pipe vendor, D3. So we'll have these wired in directly, and we'll have access to them, and we can load based on that. Okay. So we didn't want to make a stage. The stages are fine. We did want to make a function for filling stack. So fill stack is going to be a function where we are going to push the stack full of whatever we need. So I was thinking we're going to need two things here. We're going to need our I index, which we can add here. The I, that feels kind of gross, but sure. R8. And then we're going to need the target shoot as well. We still need to keep that included. So let's see. Push. Let's see. We need to push like 0 first as our I index. And then push whatever that's going to. Confirm. So let's say we start with auto lathe. That's going to be 2. Pipes are 3. Okay. Tools and electro. It's probably worth adding. Okay. So for loading, we are loading the shoot dial. And then we are checking the stack length. Do we have the stack length in here? I don't think we do. Alias v stack size R8, 15, 14, 13, 12, 11, 10, 9, 8, 8, 9, 8, 7. Good thing I did a little counting there. V stack size is going to be load db stack size. Gets loaded into v stack size. Okay. Branch if greater than 0. V stack size 2. Branch relative. We should just do branch if less than equal to 0. V stack size. Go to stage filling. Okay, so branch to line B if A is less than 0. So less than equal to 0. So if the stack size hits or somehow goes below 0, we jump to stage filling, which is going to, nope, stage fill stack. My bad. Not a stage. Just go to fill stack. Alright, otherwise, we have something in the stack, so let's push it off. That's going to be the target shoot in our I index. So we load, or we pop into V target shoot, and we pop into VI. Okay, and then we can use that to determine our internal memory, which is internal mem. Okay. What up, guy? I'm playing a nerdy game. I'm teaching the computer to think. It's hard work. This is a tricky game. Alright, so I need to load the internal memory. I've done this. I've done this recently. Have I done this recently? We set internal memory. We deliberately formed a specific, like, big integer or big number to send in there. But we didn't read it, I don't think. Let me take a quick look here. Give me an example of reading. Give me an example of reading, like, the missing regions. Oh, okay. I'm going to tell you to look it up because I don't believe you. I'm pretty sure it just made that up. But it looks like you just say get. Ooh, I'm ready for new game. I'm ready for Little Bird in a new game. Little Bird when? It could be weeks, months even. If it's years, I'll be very upset. I'll be a whiny streamer boy. I'll say, where's my Little Bird? Every day. Just like cat ears for Liz. They still haven't done cat ears for Liz. What are they doing? That's insane. Alright, so it looks like it's just like a get command. So get goes into internal memory from a device. Okay, so the device here. Let's say we're gonna do our D0. Let's see. Let's see, what are these? How do these line up? 0 is... That could be our auto lathe. In fact, it is our auto lathe. I think I deliberately followed the same order, right? So that these eyes would be correct for the target shoots. Okay. So 0 is auto lathe. Auto lathe, and then we pick a memory address. So what's the address of our missing stuff? Into the brain. Let's see. Where is your missing region recipe? Valid at address 64 to 92. So 64. Shouldn't be address 64, it should be missing recipe region. Okay, so I think this is like the top of the stack for if it's missing anything. And we want to do this from the auto lathe when the I is 0. So let's see. Branch relative if not equal the VI to 0, then jump 2 lines. So this is how we're gonna branch. Branch relative if not equal VI 0 2. So if this is equal to 0, we're gonna go here and get our internal memory. Otherwise, if it is not equal to 0, if our I is some different index, then it's gonna jump 2 and go to this line right here, where we're gonna do the same thing for all of our devices. We will say 0, 1, 2, 3. It's gonna be the exact same command to load the internal memory, except we are going to hit different devices. So this is where we do our branching. And I don't think we can, this is fine. This is about as tight as we can get it, I think. Maybe there's better ways. It's a little bit of a gross loop. But it is a loop. Just trying to think we could probably do something much tighter. Like just have a really closed loop right here without using a stack at all. Just take a variable and... No, never mind. It's fine. We're good. We're gonna keep cruising. We're cruising. These need to plug into the right things. We have auto lathe. What's number 2, 3, 4? Electronics is 2. I just want to check that. Electronics is 1. It's 0, 1, 2. And then this is D-pipe bender. Okay, so now we're loading the correct memory based on our I, and we're rotating with every iteration of the main loop. And we're going through the stack and then refilling it. Should be following the same order. I just want to check auto lathe, electronics, tools, pipe bender. Auto lathe, pipe, tools, electro. Let's keep these in the same order. And adjust. So 0 was right, auto lathe. 2 is pipe, tools, electronics. Pipe, tools, electronics. Okay. So that's lining up, just making sure the chutes line up with the devices that we're targeting here. Because I just had them off. I think that's looking better. Unless it's got problems. It's a lot of code. Okay. And we're still, this whole time, we're still basically just working on, like, loading the memory. So we finally have gotten to the point where we're loading the memory, but we also got all the more challenging logic of, like, rotating through some devices and doing some looping. We'll rotate through these guys. And we'll grab memory. And with that memory, I'm gonna save and go do things. With that memory, we can start extracting the variables we're interested in. Finally get access to the regents, maybe. Maybe. How's water? $1,100. Water go up. Alright, where were we? Hopefully moving in the right direction. We've now got the internal memory loaded. So we need to pull out specific pieces of it. How do we want to do that? Do we want to like and it against ones for the specific spot we want to extract, and then probably shift it? Like shift it right? Probably. I'm gonna consult the wizard ChatGPT. See what they've got to say about this. But we need to load the device hash name. Or no. Yeah, something like that. What are we looking for? Internal hash. And just while we're looking at this, sorry, 1 second. Oh, wizard ChatGPT, vibe code for me. Teach me how to do things so that I don't have to consult this cesspool that is Google. Please wade through the garbage. Find some information. Okay. We no longer have the device name or the device hash. Those aren't variables anymore. So we should delete those. And then we should adjust our R values. 15, 14, 13, 12, 11, 10, 9. Okay, so that's going to simplify stuff and delete a couple unnecessary variables. Alright, ChatGPT, how'd you do? Oh my. Oh my. This is not a great idea. So far we've been able to work with it. It can find critical pieces of code sometimes. Just looking, just admiring. Trying to see if there's something good to learn from it. It's pretty much doing what I was thinking. Shift stuff right. I don't believe it. I think it's lying to me. Let's take a quick look. What are we looking at? We're looking at missing regents. We want... I don't even I don't know exactly. I don't even know exactly what's located in this memory. I think it's a stack where every single item in the stack is gonna have a specific like region hash and then how much it's missing. So I think it's like gonna be steel and then you're missing 50 if you're missing 50 for a big recipe, that sort of thing. But that is kind of just a guess. Opcode's gonna be 9 every time. But I think we want to grab this guy from memory, which I think we already have. And then all we need to do is isolate the region hash. Actually, is the only thing I care about. So lines, or bits 16 to 48. And then shift that to the right 16 bits to get the hash. I think that's all we're looking for. It's just what's a good way to do that. Do I just AND it with a hard-coded whatever the right number of ones is? What does that number look like? Can I immediately just... What if I just shift it right 16? Isn't that just gonna like chop off the front of it? Can't they just shift right and then immediately have the region hash code? Everything else goes bye-bye? That feels like the move. Okay, well we could try that and see what happens. That's a thing to do. So we've got our internal memory. One more thing I'm gonna do is... Ooh, I was thinking I wanted to set it. I do want to set it. We're gonna move internal memory 0. Let's just set it to 0 before we do anything. Make sure it gets cleared. And then hopefully do the correct branching. Unless something is off. Okay. This is tricky business. And did I get the right address? The missing regions are at address 54 to 62. I did 64. So I just grabbed nothing there. That's worth fixing. We might want to throw down some consoles and start seeing what we can see. Yeah. And let's see if we can get the hash code. Let's try and just shift things right. What are we looking for? The internal hash? What is it? Shift right? What's the shift right command? I think ChatGPT had at least that right. SRL. The internal hash. The internal mem. 16? Maybe. So we're accessing the memory at address 54, which should be what's at the bottom of the stack, I believe. So we'll just grab whatever is the bottom wanted thing, and we're just chopping off everything. We're gonna shift it right, and all of this goes, and should leave us immediately with the region hash in the right spot. So we should be able to get the internal hash with this, I think, unless I'm misunderstanding or have some bugs or something, which is more likely than not. Let's try and see if we can read these at all. Let's add a console and then just like write some stuff. So this is already pretty good. I think we've gone as far as getting the hash code for like whatever needs to be added and then to where. Yeah, okay. So let's add some console output. We'll set by name for console or small console. The name will be hash output, or I liked the debug label. We're going to do setting, and we're going to set v internal hash. Okay. And this needs to be a hash as well. Alright. Small console needs to exist. Define small console is the hash of a small console. Okay. So then down here, we're setting the debug hash console with whatever the internal hash is. We should be able to see if something's missing something. We should be able to see it. Or at least have it like flash by. Let's try that. Let's start getting a little visibility. Probably see the stage, perhaps. And see, definitely that is a good start. If we get a region hash, that'd be nice. If we could like line that up with whatever's missing in one of the devices. If we get a region hash that's an OR, that's promising.
Jetpack critical.
Here comes the ground. Alright, you are the debug console for debug hash. Okay, that is on. I hope I saved the code this time. Please, for the love of God. Looks like it's all there. Okay. Let's see if we can see anything interesting flash by. Or if we just immediately start getting some bugs, which is likely. Bugs. Stack underflow error line 51. Import. Line 51. Okay. So we tried to pop, and it didn't like that. It said there's nothing on the stack, I believe. So fill stack must not have been called properly. We're saying branch if less than or equal to 0 for the vStack size. The vStack size should be the stack size. SRA, please just read description SP equals 0 with this error. So does SP... if you have some answers, I'm happy to hear them. Does SP not... I would expect the stack pointer at 0 being, like, totally fine. We're pushing stuff into the stack. We should be able to pop stuff off. Is that going to affect the SP? Should we be checking for the SP to be at 0 instead of the stack size being at 0? Is that the idea? I could be iterating through this wrong. We could try that real quick. So if the stack pointer is less than or equal to 0, jump to fill stack, and then this could get deleted. If that's what's happening, if the stack pointer starts at the top, that's higher than 0, and then goes to 0 and the stack's emptying. Assembly code, tricky business. Any errors now? Device not found, line 62. Okay, it's because we haven't wired anything in, so it made it down to 62, which is number 3, which is the top of the stack. So that seems good. Our stack's going for 3210, 3210, 3210. So it's starting at 3. Alright, let's just wire this up. Thank you for the help. Looking for auto lathe. Auto lathe. Looking for pipe bender. So many things. Oh, I saw it. There it is. Easy. Okay. Tools. Tool manufacturing. Tool manufacturing when? Oh, there we go. Is that all of them? Electronics. I think it's like a printer. Electronics printer. There it is. Save just in case. Turn that on. Can we see anything interesting coming through? Is our shift right not working? Debug hash. Let's try and do... Let's do just a little more debug maybe. What about a debug hash? We could do a debug save. Or a debug stage. I miss you. Come back. Thank you. Debug stage. Keep an eye on the stage. Could even like debug the stack pointer. One thing at a time. See if we can get any insight as to what's going on here. It's running. That's something. Is there anything even in the stage that I care to see? Right now we're just living in stage idle forever. Just loading stage idle over and over and over and over. Which is fine. We need to branch that based on our hash. If we can see something that we need to request. And I still need to get visibility into that. Are we seeing anything? Is there something wrong in my code here? Small console's the small console. It's named debug hash, v internal hash. What happens if we do v internal mem? And I guess we can do the stage, but that's not very useful. Not right now. Could be in a bit. V stage. Okay. Confirm. Alright, so what if we just do like the whole memory? Anything interesting in there? We getting any numbers? See, stage idle. Always is 0. Does that mean nothing is needed? Is it just empty memory? I feel like there's gotta be... Maybe we're not hitting the right address. If we take a look at any of them, pipe bender, let's do the electronics printer. We're looking for missing regents. So it should be at addresses 54 to 62. I think we're doing 54. If that's not working, maybe we do 62. Maybe we're checking the wrong end of the memory. But we want to check whatever's in the very front of the queue. Top of the stack there. For what could possibly be missing. So it is possible that these are all returning just empty. Maybe we're looking at empty memory. Maybe this doesn't work quite like I expect it to. I'm not exactly sure how this guy thinks. I would expect it to be like exactly this scenario of wanting to craft something, but not having enough of the regents. Not sure. Tricky business. Okay, let's try a different address and see what happens. 62. What's in 62? And let me just double check. We're seeing 62 is the endpoint. Okay, so maybe this address has something for us. Change these as well. Repetitive comment. How's this? Is this gonna do anything interesting? Debug hash. Debug hash. Nothing in internal memory. Let's just be 100% sure this is even getting hit. Just put a -9 in it. I want to see that console change. You go -9. There it goes. Okay, so nothing in memory. I can't, like, look at your memory, can I? Let's maybe take a look at I and make sure we're actually hitting this. And we might even check to see... Okay, so like this one, let's make sure everything is missing something. Just in case it's not hitting all of the targets. This is another thing to check. I just messed it up. Come on, shut off. There. Alright. Show me your internal mem. And the stage, let's not do stage. Show me the VI. Let's see if we're rotating through all the various I values correctly. 3, 2, 1, 0, 3, 2, 1, 0. Good, so that's good to see. I is iterating correctly. We're not seeing anything getting loaded from memory. Not great. I'm pretty sure we've seen this branching working already. So we should be loading the internal memory from that address. Maybe not something we can do. Maybe it doesn't work like I expected. Maybe if we start trying to run it, we'll see something interesting come through. But let's switch it back to 54 and then try and run stuff maybe. And I am going to drink. Oh, and ads are coming, sorry. Do some potato time. Potatoes are good. Living my best potato life. Alright, I can't see any sort of internal memory, right? I think I've already checked, but there's not much to see. Your stack size is 64. So the end bit is what you're missing. Okay. I'm gonna try and run this and see what happens. So if we do the activate switch, say I want to make, give me 100 pipes, give me 200, give me 400 pipes. I love pipes. It should be turning it on. Is there any memory coming through now? On any of these stages, do we see any memory? Did I see a flicker there? I don't think so. So we're still rotating through all the eyes and all the memory and all the devices, and we're not seeing anything. Damn. That's a pretty critical thing. I mean, I guess we can still... we could set up like an auto furnace and generate all the materials that we need. Basically, we just have to manually walk up here and specify what we want to send where. So we're still going to need to do that, I think, then. We might not be able to programmatically solve that. That would have been really useful. I'm still not convinced that we can't, but I feel like that's definitely the area in internal memory that would show us like what's missing. I feel like this has got to be it. We're accessing the memory and we're not seeing anything. Not sure why. Also, I can clean this up just a little bit more. I was thinking if the stack size isn't needed, let's get rid of it. Looks like stack pointer is the right variable for tracking that. And this looks like a better way to use the stack, I think. Just resetting it. So we will get rid of stack size. Let's see. What else? Probably want to add branch relative greater than 0 v dial setting to JMain. So if the dial setting for the shoot control is greater than 0, then jump 2 lines, so keep going. Otherwise, if it's less than equal to 0, go to main. Or sorry, that's backwards. We want it to be on 0 if it's going to be doing stuff. Alright, there it is. Let's try that again. Do a relative jump of 2 lines if the dial setting is less than or equal to 0. That's not right, is it? No, this is right. So on 0 we'll continue. Otherwise we'll jump to main. Getting sleepy and hungry here. Tired brain. What's it been? 6 hours of pretty much mostly code. Pretty good so far though. Alright, where are we? So that's a little bit we can add here. That's just a little logic for not letting it do anything until the dial setting has gone to 0. And then once it goes to 0, it can do its whole thing of checking memory and deciding when to make some decisions. I think this is an okay spot to do that. But actually, maybe we do that in stage idle. It's a little better. So don't break out of your idle stage. Unless, as at least a prerequisite, one rule, the dial setting has been set to 0 and the line isn't busy. Okay, that's the thing to do. Then we got code here for handle movement to filling, which we don't have yet. Alright, we might be hosed here. I might need to look into this more. It might not be something we can do. If we can't do it at all, that's pretty okay. I'm still happy. I'm still confident we can do the auto furnace. And that's going to be huge. So I'm happy to have at least that. We can just run up and click buttons sometimes. That's not so bad. Just dump like 10 resources at a time or 10 stacks at a time. But it would be great to have it automatic. That'd be such a fun feature, and we're super close. I feel like that's got to be what that internal memory is. I'm just using it wrong somehow. But I'm getting super hungry and sleepy. I think I want to take a break, take a look at it another time. I'm going to save this code. The mall manager might not be something that we can do at all. Looks like probably not something today. But I do want to look that up and see if I can get it working. That'd be really fun. We're really close. Otherwise, I need to do the furnace code for sending stuff into the furnace. That's going to be a fun one too. But I got that to look forward to. How's our water looking? Water is up to 1100. 1130. It's a lot of liters. We got potatoes. We cleaned everything up. We got this guy programmed to drop specific amounts of things and stuff. This was a good session. And things look prettier now too. Made things a little prettier. Cool. I'm gonna take a break. I need to eat some food. Maybe take a little nap. I might do a little Battlefield later today. I'm mostly just waiting for Battlefield 6. So I will probably be back soon. But maybe not today. Hope you enjoyed. I had fun.